know? So, yeah, I think that you and I have to have a conversation off live, and I think we're going to get this sucker going. But I'll still, if I get it going, wait until you got the gravity flyer. I told you I would, and I will. But we still got to get this going.
Yeah.
It's not about fame for me. I don't give a shit. You can have it.
Yeah. I always said I'd walk away when it's done. You know what I mean?
Yes.
I go out, do some interviews for a year or so, and then be done.
Yep. Absolutely.
Yeah. Everybody else can build their own, do their own thing, and you know what I mean?
I'll do seminars teaching how to build it, show how it works. And
so,
then,
guys, I'm sorry, real quick. Can I send anyone the design instructions for that device you just saw? You guys want it?
Absolutely.
Of course.
All right. I'll go ahead and sorry, go ahead, Gerald. I didn't mean to interrupt.
No. That's okay. That's okay. Squirrel moment for me anyway. No, I definitely take the design for that. That's awesome. And you've given me some ideas, Sean, when it comes to using perf board. So yeah.
Don't blow up your garage now, Gerald.
We can build another one. It's not that big a deal.
Now you sound like me. How hard can it go before it blows? Come on, let's go.
If I told you the experiment I set up before my brother moved into the garage for a while, he's rebuilding his trailer, right? So we're redoing the whole thing. We knocked it off the trailer itself. Like there's nothing, just the frame, and we rebuilt it all from the ground up. But while he's doing that, he's staying in my garage because I turned it into a suite, kind of like what you did with yours.
Yeah.
But I did a little something with the floor.
Oh, here we go. Come on.
I wrapped it in copper wire. I was tempting an experiment with a counterpoise kind of thing, right? So I've got this big copper spiral underneath the floor of what I walk on, but it's sitting on the concrete. It's grounded out.
No.
So I was thinking, you know what? If Les Brown was doing pyramid power through doing a pyramid, and a garage has two of the points of that just in its own roofing shape, I was just kind of theorizing if I used my coil around the ceiling area, I kind of wonder, if maybe I'd be able to pull more power out. I haven't tried the experiment yet, guys, but it was set up to go when my brother asked to move in. So he's sleeping on a floor full of copper, but hopefully lightning doesn't strike. Let's just say that, okay?
Oh my
God.
God.
The coil sitting on a big ladder.
Yeah.
Put some plates under his bed, and then we'll just turn on the coil and see if he lifts up. Put some big pieces of aluminum under there. Like, there you go. We want to fix your bed. So
that'd be one hell of an alarm clock, eh? It would be cold, I tell you. You get warm quick.
Oh my God, that'd be so great. Oh man.
You know what? If it was safe, I'd try it myself. But we don't know, so I'm not doing something that big, right?
Oh.
But yeah. So we'll see. I'll videotape that experiment when I do it with the garage.
Oh, you have to at this point.
For sure.
He's gonna become an urban legend. You know what I mean?
He's gonna have the coil hanging from the ceiling.
The coil under the floor is about 10 feet in diameter, so.
Oh my!
It's a little big. Yeah.
Oh, you have it built into the floorboard?
It's built under the floorboards.
Oh wow!
He didn't even remove it. He just let's go right over.
You have to move the whole floorboards and pull it all up to get the coil out. Hey, when you go big. I mean, why not?
I'd say yeah. Huh.
So I'll video it when I do the experiment. Yeah. It won't be done anytime soon because he's living in there, But
next time we see him, Gerald's gonna be like, "I got a new theory," and his whole house is gonna be wrapped in the coil.
You never know, right? You never know.
Hey, the Nunez had a design for a toroid shaped house that was basically it had the wires in a specific pattern, and it would just transmit your wireless energy.
Oh, that'd be
No
awesome.
no need for outlets.
I've got a design for a hempcrete house that will last 100 years, and you could fart in it, and it would heat it for like 12 hours. So, yeah, it's completely like the insulation in it is insane.
You sure that's not you?
Well, maybe. You never know, right? A couple cans of beans, I'm good for a few days. You know what I mean?
You start selling it with the cans of beans.
Heating
element.
There you
It wouldn't
go.
smell very nice, but it sure be hot.
You be warm. You be toasty. Yeah.
Imagine that your power goes out in the winter in Canada. You're like, well, I got the answer to this. I'll just take care of it now.
Beans and bacon. Yeehaw. Oh man.
Oh,
yeah, that's funny. But yeah, the insulation on that, the insulation factor on hempcrete's amazing. And if you build the walls a certain way and allow the natural flow of air the way it's supposed to be done, you can actually build a natural air conditioner that stays maybe 18 throughout the whole summer, no matter how hot it gets. And then in the winter, like I said, it wouldn't take much and the heat would stay in for hours. So yeah. Something I should pass to you, actually. I have a lot of designs. It would work really well in California, I tell you.
Yeah, you could light a little candle and light the whole, room or whatever, or heat the whole room. Yeah.
Pretty much. Have you guys did you watch that? I think I might have brought this up with you on a previous live. The air conditioner heating system from that.
Yes. You did bring it up, how you reverse it.
Yeah. I finally got my bathroom downstairs converted into a air conditioner heater for the winter. I'll show it to you guys when I got the rest of the drywall all done up properly. But I took a bathroom that was not used because it had shower problems and it was taken apart. The landlord doesn't want to finish it, so that's fine. I don't care. I use it as storage. But I took it and I turned it into I took 2 window air conditioners that are 450 watts a piece, and I installed them into a drywall wall that splits the bathroom. And then I have a blower fan that goes on the exhaust side of the air conditioners right into the intake of my furnace. So, and the cold side has a blower that goes directly to my basement window. So for 900 watts, I should be able to heat the house, or at least help heat the house.
Just for a frame of reference, how many watts does it usually take to heat a house?
About 3,000.
3,000. Yeah, I knew it was up there. I didn't know the exact amount, but yeah, that's
Some
insane.
say 5,000, but depends on if you have a high efficiency furnace or not.
Right, and also insulation.
Yeah. And my house is old. It's like 85 years old, and the owner redid all the insulation and pumped it into the attic. It's like, it's very well insulated. So
look at that coil.
That's gorgeous.
Guys, check this out. Ian, he's talking with me. He probably come on next week and talk about this stuff right here. He's absolutely got a killer setup going on.
That looks like a Marx generator hooked up to a Rodin coil. But what a setup in the background. He's got what, like,
I wonder what frame he's using for that coil.
I'm not sure. It's just it's an all one-way flow, it looks like, because I can see it right there. And
so
I don't
maybe
think
that's
sorry. See if I can't get it closer.
There's no interference pattern, but I mean, it still has the counter rotation.
So is that a Rodin or a POE? No, a POE is different.
It's some kind of rodent coil. I don't know if it's exactly a PoE coil because the PoE always has the interference pattern that I've seen at least. But that, honestly, the coil frame looks like Jordan's frame from Alchemical Science. It just has a lot, like maybe 32 slots.
Yeah, it looks interesting.
And that's exactly how Jordan has his wound. It looks exactly like it if you pull up his coil. But
So
yeah,
check
that's.
this out.
Oh, what's that?
Yeah, what is that?
I think it's his piezo's are in there, or no, magnets. He's got magnets in there, and then he put the flow with the different things. He was doing a solid state gravity flyer.
Yeah, that's the inverse pattern for the toroid right there.
So if you take a look, you remember Jeremiah's coils that he was talking about a week ago, right?
Mm-hmm.
So in the center of this thing, you could see him right here. He did the same thing. So he's got the bottom one, the top one, and then he's got the middle one. It's kind of like the same thing. I wish I would have shown this when Jeremiah was here, but maybe you'll catch it next week.
Yeah, that's really neat.
Yeah, he's got some majorly cool stuff going on, man.
Have you seen this thing experimented with, or?
No, I haven't seen it experimented with. That's kind of what I'm hoping too. Is he shows a couple of the things that he did, and he's shown some great pictures of this. You know, just the work that he does is absolutely awesome.
Yeah, that looks really sweet. Just the setup itself, like solid state kind of thing, right?
Yeah, I bet you it tells you a lot about how everything's done. To be honest with you, the only thing I worry about is it's the same kind of coil that Jeremiah was using, where it's flat and it wraps around, so it may not give you the breakout that you need. You need something like what you have in the center, with the top and bottom like that.
That makes sense.
So
the coil that Jeremiah had, where he had the 6 coils on it.
Yeah.
There's a video I put out that has it's circular like that. It's a ferrite core, and I have copper wrapped around it, and then I use a little 1-inch vortex coil, and I pulse it, and I'm able to light LEDs with it.
Yeah, these coils, coils based on sacred geometry and
they're
the shapes.
key.
They're very fascinating,
and
they're all
those
the key.
Those free energy spring generators.
Yeah, I don't think they would go for as long as everybody wants them to. Those had come out.
They sure look like they're running on the video, man. Let me tell you.
Yeah, you know what they do. You should build one.
Those guys in Pakistan and India, they got these huge flywheels that they spin up. They get it going by hand, and then they got springs on both ends of the shaft. One spring this way, the other spring that way, and then another spring this way and another spring that way. So 2 springs on each side. So when it turns this way, the one spring from here is pulling it back, and the other spring from there is pushing or whatever. And it's just, you could tell how the springs are working together, all 4 springs in the rotation.
You know what? Ultimately, in order to find out whether or not it's bullshit, you kind of have to build one.
It looks damn interesting, though. It's very intriguing. The springs are definitely helping.
I'll tell you this. Test it out yourself, I guess.
Mr. Tiger.
They're heavy-duty springs, too. They're not,
There's a channel out there called Mr. Tiger. The guy's he's got, I think 1 million subscribers or something. He built that little Gerard Morin washing machine motor, and he put 32 bulbs to it. And no offense to the guy, I thought he was full of malarkey. I built the same thing. I can run 32 of those exact same bulbs all day long. So you don't really know unless you build it and start playing with it.
That was my experience with the
I feel the same way about the Houdini SSG system.
It's like the alternator generators. I have an alternator generator.
I'm really prepared to comment on in any way. Is the stuff?
But when I first built the rodent coil, I had no idea it was going to work. In fact, I had a pretty good idea. I couldn't get it to work. I didn't think I would be able to.
Yeah, no, it's a complicated system. If you don't know where to start, it's what do you do, right?
There's only one
Right.
of two outcomes when you're
Right.
winding a coil. Either either you short the coil or open it by accident when you're winding it, or that's it. Or it works.
You should see some of my failures for
You
coils.
got three outcomes. Either
Hilarious.
it works, or you short the coil by accident during the wind, or you open the coil by accident during the wind.
I shorted a few while winding.
Yeah, that's more common.
Yeah.
All right, Gerald, I got a question for you on this. Okay. You added capacitors to this. So how did you get the wire out of the coil to do this?
What do you mean?
Well, you got capacitors, right? Are they just set up to the pickup or are they set up to the coil?
They're set up to the pickup coils.
Oh, that's a good question.
Yeah, those ones are set up to the pickup coils, and I believe that's a one-wire setup.
What's up, Magnetic?
So there's no capacitors directly connected to the primary or secondary coil there.
No, not in that one.
Okay.
No, in fact, I'm not even using the secondary in that one, if I remember correctly.
And the secondary is just your channel B, right?
Wait, the secondary's actually hooked up to that light that you see off to the right. It's like a square cube. And if I remember correctly, there's no rectifier in between that. It's just straight secondary.
So the secondary coil is kind of like your channel B or a second channel for that device.
Yeah, but I'm not pulsing. I just recently started pulsing my secondary. I usually use my secondary with as an RC circuit. Well,
so
I don't know
you pulse the primary, and then the secondary just kind of has the inductance from the primary.
Yeah, so I use a diode and a capacitor or a little capacitor bank to run it back into the primary, or I'll run it through this LED cube or a series of LEDs and then back in.
Oh, that's a good idea. Feeding it back in so it doesn't waste any.
Yeah.
Oh, neat.
So did I answer your question, Nathan?
Yeah.
Yeah.
I was just kind of wondering what was going on here.
Yeah,
So
that experiment was insane. I believe I have one of the wires grounded on that one. That's the one with the Whopper box because it was too bright. I remember that.
Yeah.
I'd have to look at my notes. There was more stuff that went on in that experiment. No more than you see on the hookup, just some weird anomalies. I think that's the one that made my TV go funky. I think. Yeah, I've had actually the same thing happen to you where your computer goes.
Oh,
Yeah.
Oh, crap.
And you're like, what's going on? And then all of a sudden stuff is starting to shut down. It's like, oh, no. Better
turn it off quick.
Yeah. Yeah. I actually lost the computer like that once. So
I had that stuff when you walked in my garage. It literally felt like you were the sock inside the dryer. So
yeah,
there was so much static going on around me. And
that's
I'm like,
how I know that you know what you're talking about, because I've done the same thing. It's insane when that happens, right?
yeah. You're like, I don't know if I really want to be in here right now. Like, I think I just want to get out the door.
I kind of was wondering to myself, is this really worth it? Everything I touch is trying to kill me. But
oh my God, I had one day I was adjusting the plate on my gravity flyer, right? And I'm trying to get the heights between the plates right. I forgot to turn off the high voltage. Oh my God. Okay. So luckily I didn't have my voltage multiplier hooked in at the time. It was just regular high voltage, right? On two flybacks in series. I grabbed one of them and then the wrench hit the other one, man. And I lit up like a Christmas tree. My hair was starting to stand up. It was bad, dude. I hit a massive voltage. Because everything had been building up for a while in the garage, right? So I got all this energy around me. And then here I am, the stupid idiot, touching the high voltage. And go,
yeah. That's why they say one hand in your pocket.
Oh, yeah. It was so bad that day, man.
Too easy to make mistakes. Hey, I'm not proud of it, but I can admit I've screamed like a little schoolgirl. Okay, I've gotten those shocks. And it's like so sudden and so hard. You can't even control yourself. You just scream, right?
Oh yeah.
Yeah. When I ground out my secondary in a certain way, I can't touch anything in my basement. It's a good defense system, but I can't even move.
Yeah, okay, check this out. People tell me all the time, you're not getting energy from the ground. Okay, no matter how much your Tesla's connected to the ground, you're not getting any energy from it. And I keep going back to him. And I said, look, there's a reason why Bedini always tells you that this ground over here is like it's connected to this one here, and he draws a little dotted line over to it, right?
Yep.
Because they are directly connected to each other, and they do create the capacitance right there, and it is bringing in the energy. I could tell you that firsthand because it shocked the living daylights out of me.
Yep, absolutely. I can even prove it by showing you an experiment. Do I have that on? Not sure if I have it on video yet or not. It might be. Where I turn both my signals from the signal generator at each other on the coil, and both of the how do I explain this? Right, it wasn't both the first, it was just the one. Okay, so when I turn the first signal on, it's set up for both signals to fire at each other, right? But I turn just the first signal on, and both the neons turn on the circuits, but they're not connected in any way. And the way that I've got the circuit wired into my secondary, it shouldn't be able to go through that circuit at that point. Do you know what I mean? Because it's blocked with a diode, but it flies through there like it's nothing. So my assumption is, because I have both circuits sitting on my desktop or my workbench, it's a countertop, and I think they're grounded to each other through it. But I don't know. It's just a theory, because they shouldn't both be turning on like that the way that the circuits are set up, unless it's resonance and it just slams through the circuit no matter what.
Is it wood? The counter? What is it?
Well, the energy, like when I pulsed that primary and those two neons turned on from the second one, is a completely isolated second circuit. And there's no way power should have went through it, but it did. So I mean, that's what I mean. I don't know if it was resonance that blasted through that, or if it was because the two circuits were face down, or not face down, but can down, because they're 2N3055s. I think they were grounding out through my countertop.
You might have created a scalar field.
Oh, I know how to do that. If I actually ground my coil, my secondary, to the copper pipe in the basement above my head, and I'll tell you this, I won't do it again.
What do they call that? What do they call that? A transverse wave or whatever, where it just goes through anything?
Yeah, well, yeah, I can't stop the energy. There's nothing I have that can stop it.
Yeah.
Like I've used titanium, I used an iron plate, I've used glass, I've used plastic, I put them all together. It didn't make a difference. I still got the power through the plate. All those.
There are very few who can.
I love that. I thought it was just a coincidence, to be honest with you. But I guess, there's no such thing. So what do you do? But yeah, it's just playing with, I'm getting high voltage at a low voltage input is basically what it is, right? So all the static that's being created, or energy, I don't know if it's grounding and that's why I get all those static shocks, or if it's because it's just different. I don't know. Like, I'm still working on it, right?
I think we can all agree that your system is doing something very unique, and we have to study it further for sure.
I agree. I think you guys should each have one in your hands.
I'd pulse the living daylights out of the outside of this thing and create a ring of piezo, and I'd just hit it with it. And you know what I mean with the ultrasound?
Yeah.
Because I'm like, oh, I'd love to just nail it in different directions with it. You know what I mean? And see what it does.
Did you see the ball lightning video that I put out?
No, show me where it is. I'll go back to your channel.
You actually hit it once before. It says a neon. There's a little, it's like a neon. That's all it is. It's a picture of like a big glass.
Nathan's going to put your coil on his Graviflyer, and then he's just going to use it as a transportation device.
There you go. Now you're
We're just going to see him riding it.
Oh, yeah, you will.
Right there.
Oh.
That'd be so
This
cool.
one?
Go up. Go up. Yeah, keep going a little bit. A little bit more. Okay, you see that bright light one?
This one?
No,
That's cool.
yeah, that's ball lightning. I believe that's the one. There's
Really?
ball lightning inside that neon.
Let's check this out.
And that only comes from pulsing my coil, and then it gets picked up from a pickup coil, goes through one diode to the neon, and then back to the pickup coil.
Yeah, you're cavitating something inside the air or whatever.
Yeah, because it's a
Oh,
sealed.
look at that. Oh,
Wow.
Gets better. A little bit better. There you go.
That's cool.
hold on. The wrong thing.
Yeah, you can see it.
Lightning in a jar.
That's insane. That's so cool. Well, there you have it, ladies and gentlemen. Ball lightning makes its first appearance.
You
But-
suppose there's microwaves in there?
Yeah, maybe. I don't know.
Kind of
It
the
was
same
literally-
freaking microwave.
It's literally a Faraday pickup coil with 120 wraps and one high voltage diode that comes from that to the neon and back to the pickup coil. That's all it is.
You gotta understand though, you can get to higher frequency when you compress voltage into a higher resistive coil. You know, you're pressurizing that voltage into a coil that's got a higher resistance, yet your pressure was high enough to push through it, and that's going to be a high frequency pulse.
I'm not sure what frequency, like offhand.
The frequency goes up with the voltage, the pressure. Pressure increases the frequency.
Yeah,
You know, if your capacitance stays the same and your voltage goes up, your frequency goes up. You don't have to change the capacitance to get the frequency to go up. You can.
It might have been microwaves.
That's what I'm saying. When you got high voltage pushing through a small filament like that, it has a high resistance to that high voltage, but yet it's still high pressure, so it's got a potential to create high frequency because your voltage is high.
When I showed, to your point, when I showed Jeremiah, he did the same thing, but he used a microwave transformer to do it, and I can't remember. I think like 24.
The cyclotron, yeah, it's like Nathan
I didn't
explained the
use
other day. It spins the electron in a vortex to get it up in frequency.
I only use 12 volts to do that. I don't like playing with any more than 12 volts.
Well, you know, an induction coil is also simulating a vortex spin, just like a cyclotron, but a cyclotron is way more efficient
Yeah,
for getting high frequency.
you're not wrong. I have to wonder, and this is why I want to have it tested. I'm not positive on this, but in a certain configuration of like a certain circuit,
It's a multiplier.
you use it a certain way. I have to wonder if it's a room temperature superconductor, because I can turn the coil on and hold it in my hands, and if there's a magnet sitting on my desktop or my workbench, I can push the magnet around with my coil. Now I know that's kind of normal, but the way that it pushes around is really strange. It's like there's a center beam that comes out of the open core, and I can direct the magnet with it. So, well, I mean, the definition of a room or of a superconductor is it pushes out magnetic fields. So, I don't know. I know one thing. The scientific community.
No, the definition of a superconductor is it has no resistance. It's a pure conductor.
I don't get resistance. What I put in, I get out.
I don't know what pushing out magnetic fields may then might be another part of the definition, but the simple definition is a superconductor has zero resistance.
Yeah, I don't.
It's got no impedance. It doesn't impede your voltage in any way. Your voltage and your current can be flow through it with no resistance, no impedance.
Yep.
No back EMF either. No, I mean in theory.
It never gets hot. It gets cold.
You need impedance to have back EMF, in my opinion.
Okay, but now here's my thought process. I'm not sure about that. So when it comes to a superconductor, like you said, the back EMF, right? But not only does it has back EMF, but it doesn't affect the system.
I don't know if the superconductor would have back EMF without the impedance.
But that goes to the definition of a superconductor in the sense where, yeah, it doesn't have impedance, but how does it not have impedance?
Because it's a superconductor. It's not a semiconductor. It's a perfect conductor. There is no semiconducting here. It's a full-on 100% conduction. There is zero resistance in the line. You're not going to have any loss in your current. That's a superconductor.
Okay, so maybe I'm wrong, but when I put whatever voltage in, I get that out plus, no matter what I put in. Magnetic fields can't get close to this thing when it's being pulsed. It never gets hot. It gets cold. In fact, the more of the load I stick on it, the colder it gets.
If you're running at a nice resonant frequency, there wouldn't be any heat. And I wouldn't be surprised if it got cooled down too.
Yeah, so you guys are describing the same thing. It is a superconductor.
A stable
frequency,
frequency, a nice clean. If it's not a sine wave, you're not feeding. You're giving it DC pulses, right?
I'm using DC pulses, but I get a sine wave on the outside.
Square waves? You're feeding it square waves?
Yeah.
Yep.
He just doesn't have to have it.
Square waves are very nice signals, nice and clean signals.
Yeah. I get more out with a well, I don't get more out. I get not as much out with a triangle wave or a sawtooth, but I still get excess power out.
Well, the cold energy in and of itself is evidence of negative resistance.
Yeah. See, that's why I kind of wonder whether or not it's a superconductor.
Just negative resistance.
I believe it is. That's my belief.
Doesn't negative resistance imply superconductivity?
Yeah, that's what I'm thinking.
Has to say not exactly zero resistance, but below zero resistance.
Okay, but superconductivity
zero resistance, which is kind of hard to imagine, but
so it's beyond a superconductor because it's getting negative resistance. Yeah, no, you're right, Mike. You're absolutely right. It's a different category altogether. It's beyond because it's getting negative resistance.
Resistance means it's not a superconductor. If you have negative resistance, meaning superconductor.
No, I thought superconductor was no
negative resistance in the two words imply not zero resistance, but below the zero line, the negative side of zero, which is less than zero.
Which is what I got.
Which is hard to fathom or imagine.
It is.
There is a metric for that. And literally speaking, there is a metric for that.
See, when you're conducting, you put in power. Say you put in 10 volts. The line eats some power. The resistance eats some power. Your circuit eats some power. When I put 10 volts into my circuit,
I mean, if you're giving it the bottom half of a sine wave, you could technically say you're giving it negative energy.
Well, I'm getting a minimum of 20 out when I put 10 in, no matter what I do. I can't
throw out. Let's say you convert the positive side of a sine wave and make it a negative, and it's all negative. You're keeping the negatives. Let's say you're feeding your coil AC and not DC. And you're taking the top half of the AC and making it a negative like the original negative that you have to start with. And now you have an upside down McDonald's sign feeding your coil with negative, energy.
Yeah, I can accumulate that on the outside if I'd like.
You can pulse it with a negative portion of a sine wave.
See, this is something that's gonna. You know what negative energy is, Mike? It's back EMF. That's what it is. They don't want you to know that. They'll never admit it scientifically.
Well, technically speaking, the
Physics
negative
will
side
laugh
of
at you.
the sine wave is the lesser potential side of the greater side.
You have to have a perfect mirrored image, though. It has to be the same frequency and just the literally negative sine wave. Back EMF, if it's done right. I believe I have that. Do I believe I have a superconductor? I really don't know, but I suspect that it's somewhere borderline on superconductivity because of the way that it operates. Because when I put in voltage, it doesn't eat anything. It gives me more out than I put in every time. In fact, my watt meters don't even register half of my loads, if not more than half. So what do I do with that? When they say that a superconductor conducts perfectly, well, that means that if you put 10 volts in,
I wouldn't worry too much about whether it's a superconductor or not. You don't need a superconductor to get, even 100% COP can do amazing things.
You're right. But a room temperature superconductor, by definition, would help so many people. It would be insane. So if you're getting, like I said, if it's more than a superconductor, like you just said, then that's even better. But getting
negative resistance, to me, the term implies exactly that. Negative resistance, meaning there is no resistance in the line. In fact, there's negative resistance in the line.
Yeah.
Where is the impedance in the line? Where is the room for back EMF to be generated through the impedance? I mean, you need a form of resistance for the pushback.
Oh, I see what you're saying. I get impedance. Yeah. Well, I get impedance from the primary, but I capture that impedance in the secondary, which negates it altogether.
You capture the pushback as a result of that impedance, you mean?
I capture the pushback, which is back EMF, negative energy, call it what you want.
I mean, technically, the coil, you're filling a balloon up with air and it's unloading the air back into the other coil, kind of thing.
Would you say that the back EMF or pushback EMF or electromotive force is the pushback of the ether? Or
it's transfer of potential,
no.
pressure is voltage.
I think it's part of the formula to capture.
Part of the formula. Right, like it's doing something to the ether at that point, right? Maybe like spinning it in a certain way.
Well, when you transfer potential from one location to the other, from one greater potential to a lesser potential, you also have the potential to have other ambient energies flow along and catch a ride with you. And that's probably where the excess comes from.
One of the biggest mistakes that physics made was to take the negative part of electricity out of physics altogether. And when they did that, they negated so many things that could have been found in the last 100 years. It's insane. So is back EMF negative energy? Not so sure. I kind of lean towards it being negative energy, but it definitely is on the negative side of the circuit and it performs work.
Didn't Tesla call it dark energy?
Yeah, dark energy.
Dark energy.
Yeah. You could call it that.
He did a whole paper on it, lecture. It was really awesome.
Yeah.
Where do you find this stuff?
You got to search hard, man. Tesla didn't.
Let me tell you about my boring life. If I'm not working on the gravity fire, I'm reading lectures by everybody who does electronics in the
online or in books.
No, I read it online, and I can send you the links, Mike. Usually,
if you find like good lectures from Tesla that are like 5 or 10 pages, that stuff I can.
Okay, yeah. Again, I find them, I read them. That's what I do. I like to see how things work. I love the circuits in them. I love to see the design of them. I've been looking into Steinman's because he's describing AC and how everything particularly works together. And it's absolutely amazing what he saw and how he converted, such a big math equation down to a little one. It truly tells you he understood the energy around it and what it was doing. But the best by far is Tesla when it comes to some kind of a dark energy, a reusable energy, a back EMF, anything that doesn't put a loss in your circuit, the absolute best.
Yep. Absolutely, I agree. I'm just getting into that Steinmetz book, Waves and Impulses, and
Steinmetz is the one that dampened out a lot of stuff in order to get the thing to work.
So the negative and negative electricity is referring to the motion and not necessarily the charges. They're still negative electrons.
well, here's how I see capturing the ether. I think you need a positive charge and a negative charge flowing in certain directions, and then
See, that's what I always envision, a positive to balance it out.
Yeah, well, the positive would create the dipole, and then the negative would be your tap line for that dipole. And if you can revert it back in or convert it back into your positive, you close loop it.
Huh. Well, that's interesting.
Positive potential is going to want to fill up the lesser potential. Your negative is the lesser potential. The positive has more energy than the lesser potential. The lesser potential has energy. It has less energy than the plus energy.
And
which
when you
means
take
the extra energy in the plus side is going to move to the lesser side.
Mike, and when you take the load off the negative side, you create a hole, and that hole has to be filled. What's it filled by? Not positive energy, not negative energy. The positive energy is being used to create the dipole. The negative.
That's a good way of putting it, Gerald. So it's being filled with, replaced with negative energy, which is plenty of lesser potential all over the place. So
you're still thinking in engineering terms. There's a third component you're missing.
The lesser potential is the negative energy. You are creating the greater potential. You are drawing in the lesser potential. It can flow to the greater as well. It's just a biflow effect. It's not one direction. We just think in one direction to educate ourselves. Okay.
I never said.
I sat here and told Ben that the negative flows to the positive and the positive flows to the negative. Ben would quit this shit right now. Okay. It's just going to blow his brain up. And like, this doesn't make any sense. You can't teach like that. But
okay, so how do you?
If negative meets the positive, then positive meets the negative. They meet each other. Okay, the two potentials meet each other. Not one potential is doing all the work and traveling to the other. They meet each other. Just think of it like that. They meet each other at the junction. That could be a diode. That could be a switch. Whatever the junction is, the light bulb, the load. That's your junction. That's where the positive and the negative will meet each other, but they're going to come to each other from each location that they're currently at.
You confused me right there. So I.
But yes, it's confusing. But so for now, the positive goes to the lesser potential. The greater potential is going to fill up the empty bucket.
Okay, well, Mike, you're using engineering terms. And you're going along the same lines that you were taught, and I understand. I'm going along with what.
Well, once that's understood, then you can see the negative going the other way, and it does cross the cathode of a diode. Okay, it does get rectified through the cathode of a diode and out the anode. Although they don't want to teach you that way because it just confuse you. So they tell you that the positive energy exits the anode and goes out the cathode.
Yep.
Which in reality, both is happening, but they're meeting at the junction of the cathode anode.
If you could separate those charges, then they're no longer going through the same junction, and it becomes a lot faster without resistance. Hey, Lulu.
Hi, everyone.
With the high voltage diode, he separated the charge off the coil, not the switch.
Mike's
hey, how you doing?
Hey,
Hi guys, how are you guys? Sorry, I just saw the email.
There you go. What do you got to say about all this?
I wasn't listening before. I just saw the email, so I clicked on the link. So tell me what are you guys talking? Where are you?
Oh, you're missing a barn burner.
Negative energy flow.
Mike's talking about negative energy over here.
Yeah. And I'm trying to explain it from my point of view, and he's trying to explain it from an engineering point of view. So it's kind of like two people coming to try and explain the same thing from totally different angles.
It's different perspectives.
Yeah.
No, actually, Gerald, if you heard me earlier, I actually agreed with you. You stated it correctly. But anyway, go ahead.
No, I agree. I know you're agreeing with me, but the way you're explaining it and the way I'm explaining it, just
you were
Yeah, they're
explaining
just
to Ben, you were
communication.
explaining to Ben that
So
positive
I
energy
have a
flows to the
question.
negative.
If two negative currents meet, do they turn positive?
that's interesting
Law
question.
of mathematics. Negative and negative makes positive.
Well, from the greater potential
but-
positive through the light bulb to the lesser potential negative, that flow through the load has resistance, and that causes excitement in the materials and gives light. But the flow of electrons from the greater potential positive terminal of the battery to the lesser potential negative terminal of the battery, for now, that's the flow. For now, that is the flow. That is the flow for now. On the way there, it lights up the bulb because it's in the way. It's
that's not how my system works, Mike.
it's impedance. You know.
Okay.
So the bulb is impeding the flow.
Go back to the water analogy with
creating
that
like a little fire, of heat.
I mean, it's the order of operations. I'm thinking of it like in mathematical terms. Negative times a negative, you cross two negatives, it becomes a positive.
Well, I'll give you my.
And if we envision our heads,
the positive
two trenches of water
through the center of the
back and forth, and then meeting at the negative, both negatives meeting
of the wire.
Right? It should make positive.
The positive
correct
flows to the negative through the center of the wire. The negative flows to the positive outside the wire.
Okay, you guys want the answer?
Yes. Yes,
okay.
Please.
Yes.
You take two negatives and you touch them together, right? You would think you get a spark out of it.
Nothing. Get nothing.
Get nothing. When you connect two positives together, you get nothing. So here's the thing. They're also part of the same circuit and they just close the loop. That's it. That's as simple as it gets.
What would the charge be?
You're not making a positive out of it because you're not changing the energy form to make it aggressive towards it.
Only if the two positives have like one's 15 volts and the other 16.
But in a normal system, you'd have the same value coming out of the same spot.
Right,
now,
same spot.
Two different spots, you're going to get obviously a cross there, and you probably would get a spark.
And you're talking with a regular system, and for that, I agree. But when I pulse two positives towards each other, primary, secondary, I get more positive out.
Well, hold on. You're creating two different positives. One's got a greater potential and the other's got a lesser. Now you have a negative.
But they're both
terms,
the same.
that other positive you created is a lesser potential to the greater positive
they're
you created.
both the same potential when they're getting pulsed at each other.
But you're going to have a spark because you're going to have flow because you have two positives of two potentials. One greater, one less.
It changes the frequency in it. So you're changing the voltage and amps in it. You are converting into a total different system. You have two different ones going on now. It's no longer the same energy. Even if it's produced at the same source, you've manipulated the energy in the secondary.
So the oscillation both frequencies would go a level higher because they would become coherent. Right?
So constructive interference is what you mean.
Yes. So now you have a chance for resonance. Now you have a chance to get them to work together.
Okay.
So
makes sense.
If you can make one resonate to the other, just like a Tesla coil would, then you have something there. You get what I'm saying? It's a push pull. You got it working.
I think an H-bridge circuit would work for that. I'm not positive though. An H-bridge is a push pull for motors, right? So what you're using when you go from your motor controller to your ZBS, and then from your ZBS to your Tesla, your motor controller is actually a push-pull circuit. It's an H-bridge.
Okay.
So yeah, that's I haven't tried that yet. And there's a reason I haven't tried that.
Oh, come on now. What's going to blow up on you? Probably everything.
I don't think it's going to blow up. Honestly, I think it's going to do exactly what you're looking for.
Well, that's good though, isn't it?
It is. It just makes me a little nervous because once you get to that level and it's that simple, even though it's not simple, it kind of changes your perspective on things real quick. You know what I mean? So I've been nervous about trying that experiment because if it does go the way I think it will, then Yeah. Kind of
Like-
changes things.
I'll tell you what, Gerald, I was nervous the first time I hooked in my Variac on the DC side. I converted it to DC, and I put it into my Tesla coil because it resonates so well. Okay. 0 problems. It's perfect resonance. Okay. I was scared to push that sucker beyond 40. Okay.
Yeah.
It took some real big ones to push it up to 80 because of the amount that it goes out. Like,
yeah.
it literally forces this thing completely out. And there is like, you're looking for sparks out of the top. There is no sparks out of the top. And this thing is just a gigantic field. And you're like, okay, I need some longer wires here. So
yeah.
I bought 100 feet of coax cable because of the insulation on it. And I ran it from that. Okay.
Wow.
I did not want to be around that.
You know how to pop the bubble, right?
What do you mean?
Okay, so when you create the bubble, let's say it gets too big or it's too overwhelming or you want to just stop for whatever reason, pop off a capacitor. The implosion of a capacitor for some reason pulls all the energy in from the bubble and just stops it cold. I found that out actually through many experiments. It's that loud impulsive snap that literally stops it cold. That's why I think when you create a spark, there's a problem. Like it shuts your buildup because that spark is an implosive reaction.
It sucks in all the energy right to it.
Yep, exactly. So when you create, like you say, you blow up a capacitor or you just short it out and it makes that pop. Well, it's the same thing. Pulls all the energy in.
I'll be honest with you. On the ends of these high voltage things, I'd much rather use something like a felt or something, but it keeps burning up on me. I want to create a capacitance to the plate, you know what I mean, through a dielectric instead of having the wires touch it because I get a spark.
You ever thought of using an electrical brush out of an old drill or a universal motor?
No, but
it's like a piece of carbon with a spring on it. You know what I mean?
Oh yeah, no, I got it. I know exactly what you're talking about now.
Yeah, that might actually work for you. I don't know, but it might. I was thinking about that the other day. Rather than using copper and how you're creating sparks and you're kind of burning out the copper on that line, what if you used carbon as if it was like a carbon brush?
You know, carbon is what they use for brushes anyway.
Yeah. Well, that's what gave me the idea. It might create less spark, and you'd be able to transfer that energy.
Make your own spark gap out of carbon deposits.
You could, yeah.
Just by spacing materials right, you can get, little sparks.
Just a thought.
You know
like
what?
The solid state cells that they're making, you can put carbon deposits in between the plates and it act like because carbon is kind of a conductor too, so you got to space it.
Yep.
Right. And if you have the right amount of space, as long as they're not touching, they're still insulated, but there's such a minimal air gap, there's going to be a spark. Yeah, it's hard to do though. It's hard to fabricate that kind of thing. You need like the kind of equipment that makes microchips.
But he doesn't want the spark, which will work perfect.
Right. No, it's a spark you can't see. They're like quantum sparks.
Interesting.
Because you got, the, what's it called? The
gravel flyer?
Casimir effect.
Oh, the Casimir effect?
Yeah, that one, Casimir. The plates really close together.
Right.
Yeah. If you had that with carbon deposit plates, still isolated, from you touching, but it's close enough to where it's like a spark gap. But you have a lot of surface area too. So you got, and it's low voltage. So whatever sparks are happening are going to be invisible to your eye. But you got the surface area there. That's the whole idea behind the cells. Get the transfer of energy from one plate to the next.
I had a Casimir sweater once.
Without actually conducting the two plates,
Well, I need something light too. So it's like
semiconductor.
look like a film, like just with the plastic coating on the outside, but it's like a metal on the inside, and it just comes around and it's very light and springy. Something like that is what I need. It cannot be where it's rough metal against metal. It's got to be something with some kind of, you know what I mean, just a little dielectric in there, just some kind of little plastic. That's enough because it's going to transfer the energy just fine.
You're using
What
high
about-
voltage.
Would that work?
I'm sorry, say that again.
Metamaterials.
It could. It has to be depending on which one. Like I said, it's just got to be a very light coating on it. I could.
Sorry.
Go ahead.
What about silver gift wrapping paper?
No, he needs an insulative coating.
Hold on, I've
Right?
got.
I don't know. It's just a thought, right?
Because you're doing high voltage, you don't want too much current flowing. You want the voltage to the signal or whatever.
Yeah, because
Yeah,
right now I just used aluminum tape, and it covers better, but it still gives off a little bit of a spark once in a while.
I collect
It's
these.
too conductive. That's why.
I collect these things. This is a metamaterial. They use this like when you do the microwavable pizza. You put it in the box, and it's supposed to like shoot out the microwaves to cook the pizza better. But the stuff
Yeah.
is a metamaterial, so I collect them because you're describing exactly what the material you need. It's coated with a shiny, coat, but it will still transfer electricity.
And what kind of pizza did you buy to get that?
From
There we
Kroger.
go.
Yep, this is what kind of pizza.
All right, I'm
It's
buying one.
$1.
That's
It's-
interesting.
Yes, and they have this inside
Yeah,
of
that's
it.
really cool.
Huh?
You made me want to go buy a pizza to do experiments.
I know.
That's awesome.
Whatever you do not let Gerald warm it up for you. We heard about that one earlier. He
It's
was
true,
burning
you
down a
should.
room.
Charles, how come you never try AC on your coil? It's only DC is what you're going with, or
Yeah, I'm a little nervous about trying AC. I haven't
no
done
low
it.
voltage AC, low voltage, low current. You can get
Yeah. I was just telling Nathan that because I think it might do something really amazing. So I've been negligent.
because AC is going to flip the poles back and forth for you.
Yeah, but what if he like puts in a really tiny amount of current and it just like exponentially outputs an enormous amount?
Well, I was kind of thinking the same thing as John Searle.
No, it's just gonna take off and hit your ceiling.
gonna go Boom. Right?
A variac.
That's
you
what-
need, you
when
need
he
like a
first hooked
variac.
up his-
You run it at 8 volts AC or something.
Mhm.
So
When
that
he
was
first
what I
hooked
was
up
gonna
his
ask you.
generator, it took off and almost put a hole in the ceiling.
So a variac, it puts out AC between like 0 and 120 volts, right?
Yeah,
That's how it
you
works.
could go to 1 volt AC. Try that, and if you want DC, you could put a diode on the variac and get your DC.
All right, I'll hook up my variac to
You
it.
got DC and AC with the variac. That's something I never got is a variac. But
Okay, so I'll do that tomorrow then, and
I
I'll
think
put it
it's
on video.
totally
And if it does
necessary.
anything crazy, maybe I'll do a live. If it does something
and if,
crazy.
if you've never tried flipping the poles on there, you could do it with DC also.
Yeah,
I
I'll
flip
get on
the
there with
poles
you,
all the
Gerald,
time.
if you want.
No, if it does something crazy, I have to go on a Zoom call with Nathan.
AC
right
is
away.
just easier.
Okay,
Well, bring
check
him
this
on.
out.
Yeah.
Put this in there on your variac. Okay. It's going to look absolutely wrong. What it's going to give you is an AC. How do I want to say it? It's like a half bridge, but then
Oh, yeah.
it's a skipped half bridge. So one loop over the top, space, one loop again, space, just like that. That's what I run in my Tesla coil.
And what is that? That's just copper wired? No.
So look at the diodes right here.
Oh yeah, okay.
So they look backwards, right?
Yeah.
It's a
So
half
there's
bridge.
your hot line, and then they go in there, and it looks like it's going to stop it, right?
Yeah.
But it's only stopping part of the wave. So
Oh,
the variac,
what you did?
so the variac's on the other side. That's where all the 3 lines are coming from, just so you know.
Oh, that's kind of cool.
Well, that's not me. That's Sean.
Really?
Yeah, he's got this. I told you, he got these Tesla coil thing, Matt, just absolutely insane.
He understands how
He's
energy
creating
flows.
DC with the variac. He's blocking the backflow with the other diode. It's like that's what he's doing there. And the other
and
one's
he's-
ground. What's the
Well,
third
he's
wire?
blocking it and he's pushing it through one way.
I see 2 wires.
Yeah. So let me see if I can't. I'll pull up.
You said there was 3 wires, Nathan?
It's 3 wire. Hold on. Let me take a look at it. I'm sorry. Yeah, he's got 3 wires coming out of his variac. You see the black is hot, the white is neutral, and the ground isn't used.
Oh, ground. Okay. All right.
Yeah.
So I was thinking it was. I didn't know variacs had grounds. I didn't know they put ground on. I guess so. Why not?
Yeah, so hold on. I'll show you.
You probably don't want to use the ground for your experiment, though, unless you need the ground for something. Probably use your own ground separate from the variac, because I don't know, you're getting the neutral off the grid. And you know how this flyback likes to ground out to the ground. If you have a ground on your variac, it might go to through your variac.
You're an engineer. You should know that the grid's not always at 0.
You could put another ground for the system that the variac is feeding. So if there's a ground event, it doesn't go through the ground on the variac. Just by, it'll go through the neutral on the variac, which could be worse. Yeah, just go ahead and ground the variac. Never mind. Forget everything I just said.
Fair enough.
So this is a power that it puts through this thing, guys. Let's wait till I'll show you in the dark.
Hey, having more than one ground is the best way to protect your equipment, I think.
That's true.
So in the back behind it's the inches.
Wow. You're in the 10-inch mark?
Yeah, it's going up to 11.
Wow. That's a lot of juice.
So if you have a light bulb close by, it could probably light it up.
Oh, it lights up everything.
Okay. Yeah, makes sense.
Yeah,
Probably lights up half the room. That thing's gorgeous.
Yeah, it's getting up towards 12 now.
Should catch some mosquitoes and bugs and throw them in the room, see what they do.
Throw them into the flame.
Mikey,
If it repels them or not.
Yeah. No ground.
That bug machine is the same concept.
See how far you could place some house flies, let them go right there, and see how far away they fly. If they fly away,
they even make it. Yeah.
Or if they hang out, then I don't know. But if they dip out, then your answer. They don't like it. So.
Yeah, that's beautiful plasma.
Yeah, I'm telling you, man, this stuff is wild when we build it.
See, and that's the thing, that the coils with geometrical shapes that are compactly wound, they create plasma. But it's not a plasma that you see. It's in between the lines. Because you have charge going one way and charge going the other. And it creates a static form. Right? Because remember, copper is the energy goes around the wire, in and around the wire. Because it's so compact, it multiplies.
You get that temperature differential through the 2 flows of charge.
But with a Tesla coil, it's straight multiplication. It has the same effect, but it gets it there differently. I think that's just amazing.
Yeah, but when you have temperature differential, that's all you need to make plasma. And if you have electric flow in 2 directions, which is what it does anyway, one has got more heat than the other because one is greater potential and the other is a lesser potential. So you're gonna have temperature differential.
That's a good point. I didn't consider that.
At a scale that's not typically perceived.
Yeah, Nathan was teaching me how to view heat in a different way. I didn't think it actually came into effect.
The lightning bolt is no different than a tornado.
Yeah, he plays a big role in your voltage. You just didn't know.
It's just a tornado moving at a speed that you can't fathom. That's instant. Like a tornado that moved at lightning speed.
Yeah.
And because it's moving so fast, it got compressed from the size of a tornado to a thin lightning bolt. That's just the the speed, the frequency of this energy is much more than a regular tornado. Has a lot of energy, but it's slower oscillation. And a lightning bolt has a lot more energy, a lot more potential, and that means its oscillation is a lot faster, and therefore its presence in your timeline is a lot quicker. And
well, I know this: when you ground out these systems and create static in your room, like I was saying earlier, it feels like a lightning storm's coming.
Yeah.
Yeah. Feels like you're standing outside and the lightning storm's right around the corner.
So I get that smell in the air.
Yep. Yep.
the ozone, yeah.
If there was moisture, you'd literally think there was a thunderstorm in your house.
Yeah.
Crazy.
You can make the same ozone with ultraviolet light bulbs, but they can
Not as intense, but yeah, you can. Yeah, not as intense, but you can.
Right, it's not the same intensity.
Yeah,
Depends on the bulb size, though. If you get a decent sized bulb, it's super strong.
Yeah, like a big one. Hey, like a super big one. Yeah,
but that's not so healthy though, because
no,
they say it's not. I don't know.
it only causes cancer. It's okay.
Why would it cause cancer? It's O3. I don't know.
I'm kidding. I'm kidding.
Might oxidize your lungs, if anything.
Yeah,
burn your lungs.
Wouldn't that create lung cancer though over time?
Free radicals from the oxygen, maybe.
Yeah, yeah.
The oxygen is a free radical, so
It is.
you got to stabilize the oxygen with your glutathione that your lungs produce. It stabilizes the oxygen you breathe through the use of selenium and magnesium to produce the antioxidant that we call glutathione, GSH. And that contacts, I'm guessing that contacts the oxygen that goes into your lungs and stabilizes it because in the air it's already radical. It's not stable.
Yeah.
You got to slow it down. You got to slow down its frequency because it's too fast and it burns you. It's oxidizing. So that's what kills us, oxygen. If anything else doesn't kill us, it's going to be oxygen.
So Mike, you and Nathan are the only ones I ever heard of talk about voltage as frequency. I've never heard that.
The voltage is pressure. The more pressure you push, the faster the vibration.
Right. Why?
It's like rubbing your hand on a wooden table with more pressure. You get more bumps in your hand. Faster bumps.
Well, see, I know it's pressure, but I never thought of it as frequency because of pressure.
Well, because you could use pressure to create vibrations by rubbing your hands, like that, The less you push, the less pulses you create in your hands. The more you push, the more pulses you create. That's the frequency. The more pulses you make in that push, that swipe, by creating more pressure on your hands in that one swipe, you create more pulses. And that's more pulses. So more pulses per second is a higher frequency.
Check it out, guys. I made the plasma channels thruster. His ion thruster. That's what you're looking at right here.
That should work.
Kind of like using high voltage to press against a quartz crystal to create a high frequency because you got the high pressure.
Oh, yeah. Yeah. Charge density due to pressure.
Although you don't really need the high voltage with quartz. They take any voltage of a range that doesn't destroy them anyway. And they'll put out their designated frequency that they're already sized to create. That's what's so good about them.
I love learning. I learned
you
something.
You can even remove the voltage, and they'll keep generating that frequency for a little while.
Is that Jay's reactor that you have on there?
I built it.
You built that one?
Yeah.
No way.
This is I built the STL. I put in the rods in it and everything, and I put wire in the top, and I built the plasma channels ion thruster.
Nice.
So here, I'll rewind it a little bit for you. But you have to take a razor blade to the wire in order to make the breakout points on the magnet wire. in order for it to work right.
Oh, really?
Yeah. And then you put in copper at the bottom. I put it in a teardrop shape, but upside down.
Yeah.
And so the points at the bottom, and it flows. And it's just two DC flybacks in series.
And you have a motor controller running that?
That's just it's just a ZVS and two flybacks.
Wow.
You're doubling your voltage flyback like that?
And it makes a high voltage hiss.
Huh. I want that.
You can see it breaking out on the outside too.
Yeah.
Yeah, the higher the voltage, the higher it's going to oscillate, the higher frequency.
I use that to heat my lunch.
Yeah.
Yeah,
That'd be awesome.
I'm actually trying to.
Question: I have one of these things. Can you see it? Like,
hold on, give me a second.
Plasma globe. Yeah.
what if I take off the glass and connect instead of the battery, it connected directly to the electric outlet? Will it spark the same way how that thing was sparking earlier?
No.
No.
No, because your glass bulb
There's gas in there.
Yeah, it's a sealed bulb, right? And when you pull it off, all it is a wire that comes up into like a sealed bulb tube with a little bit of stainless in there, and that's what creates that ion, so that I think it's so that it can fill the bulb.
And then there's a little bit of gas in there to enhance the lighting effect.
Yeah. You can pull energy out of that thing if you wrap it with aluminum foil and then wrap copper wire around that aluminum foil. But unless you know what you're doing, I don't suggest it, because you'll pull kilowatts of power out of there all in like a split second.
Yeah.
Yeah, they're basically Tesla coils, aren't they?
Yep. Yep. That's what I used to make my my coil hop, was the power from one of those.
No.
It's 3,000 volts, and I think it's 3 megahertz. I think I could be wrong on that, but yeah, don't get electrocuted from one of those. They hurt.
Don't try this at home, kids.
Exactly.
Exactly. We're just talking in theoretical. Theoretical.
Yes, of course, theoretical. Right. That's what I've been talking. I'm kidding.
It's all fun in theory until someone gets hurt.
Exactly.
All right.
Go ahead.
I got another one for you guys, okay?
I don't recommend anyone doing these experiments unless you've had previous experience or somebody that knows what they're doing around. It could be dangerous.
DC flyback with foil.
What was that, Lily?
I said very good disclaimer.
Yeah.
So watch the foil. As soon as I hit the voltage, and there's only one wire attached.
Oh.
Yeah, that's cool. It's like sucking down, isn't it?
Yeah. It's
That's neat.
charging the table right below it and charging the actual aluminum to suck together like this.
Is that what it's doing?
So when I talk about charge and I talk about putting things on your table, I tell you not to do it. That's why.
And that's a wooden table?
Yep.
Oh, okay. I got something to explain to you then that I never thought was significant until this moment.
Okay, go ahead. I'll take this off screen.
When I pulse my coil, and I have it pulsed one way, let's say I put a magnet underneath it and it lifts, right?
Yeah.
Well, if I flip that coil in the opposite direction and move the magnet, it literally sucks towards wherever it's on. Like the minute I start pulsing it, it goes down.
So your amps are really low, right?
Yep.
So you're getting a charge. So when I tell people about charge, they're not understanding very low amps, very high volts, and it'll start charging things. Okay? It's not misleading. Then the charge turns to magnetism as soon as you add heat to it or you add amps. It immediately flips.
Oh, you just blew my mind. I just got it. Okay. I'm going to do the experiment tomorrow. I think I just got it. I'm not going to show anyone, though, because I already promised Nathan if it does it, I'm waiting until the grab flyer does it first.
Ah, shit.
Sorry,
I just
guys.
have to wait.
Now,
No,
now you
it's
understand
okay.
what I'm doing, right,
Easy.
Gerald?
Yeah, I do. I totally do. I get it now. And now it means even more significant when I said I know how to flip the pole.
Yeah.
So, dang, that was a very significant piece of information you just told me that I was not aware of.
Yeah, the reason it turns to magnetism when you add amps is because the amps establishes the flow. And the flow creates the magnetism.
It completes
The voltage does not create the magnetism without the amps. It creates the potential. But that doesn't mean you can't use potential just because you don't have magnetism or amps.
Oh no, I know I could use potential, but
You can transmutate potential over time. As Bedini said, nature takes time.
Yeah, I get that.
You have to give it the potential, present it the potential, and allow it the time to convert it. It's not going to happen instantaneously.
I just wasn't aware that
That's the only way to get the free side of the energy. I
get that, Mike. I just wasn't aware that I was charging my surface of where the coil was sitting.
Yeah. And the device that can receive the negative potential is like batteries, are good at that. And I don't doubt that a coil can do it too.
I have a battery that I've been charging with negative potential. You can't charge it with a positive battery charger anymore.
So the Grab-A-Flyer is basically doing the same thing as the foil's doing with the table, only in reverse?
No and yes, I think. Let me explain this one. Nathan, tell me if I got it right. From my understanding, it's charging the surface it's on, and then when he flips the pole or taps that center plate and the pole flips, it pushes off that charge.
Yep.
Is that correct?
Current.
So now, hold on. Let's go back to your experiment.
Okay.
You jumped once and had it steady. Now you jump again.
Yeah.
Now you understand, right? It's an immediate shift. So on one side, I need one thing. On the other side, I need another, right?
Yep. I get that now.
Now it's jumping on top of, it's like stair stepping its way up.
Oh my
God. You can't have one without the other, and then it just steps up, huh?
You see why it's so difficult to put this together to get it just right on the hover part.
Yeah, there was
Sorry, go ahead, Ben.
Oh no, I was just gonna say there was a guy on Apex saying that his team was trying to get the Grab-A-Flyer to work for like 2 years and they couldn't get it.
Listen. If it's a frequency dependent device and you don't have a crystal oscillator, it's not going to work.
Yeah.
Just like an AM radio will not work without a crystal oscillator.
I got
an FM radio or a cell phone.
It only needs a piezo disc. It doesn't need a crystal oscillator.
The only way it can work without the crystal oscillator is if the piezo disc or the disc and everything, the geometry of the flyer is exactly accurate. There's no, it's exactly the size it needs to be per the frequency it's receiving. If it's not, then you need to adjust that with a crystal oscillator. And
so hang on a second. Let's go back to where we're talking about the stairs there, Nathan. You know how you said it went up once and then it went up again?
Yes.
Just like a radio station.
I think what you just described to me in my brain, I just got how I know how to put it up another time. And then another time. Maybe even keep going. I have some experimentation to do now. You've blown my mind. I've learned more off of you in the last month than I have off the whole freaking scientific community in the last 4 fucking years, pardon my language.
Hey, Gerald, it's because I know what I'm doing. I get the experiment.
But does that now mean, does the scientific community not know what they're doing? Are they willfully ignorant? Or are they just willfully not?
Function generator has crystal oscillators.
All of the above.
If you're using a function generator, you're using crystal oscillators.
Okay, I'm not using a function generator. Okay.
Well, Gerald is.
Anyway, listen, I try to explain things to people, okay? A lot. And it just seems like I'm throwing my email away. Okay?
Yeah.
You do not understand what I'm saying. And I don't know if it's the way I talk. Sometimes I think I don't talk scientific enough for them to understand it. But the fact is, they just don't understand what I'm doing. And every time I try to say it or show something, they're like lost in space. Yet,
or I got one worse for you. They understand
like that.
Well, see, here's the other part that could be worse. They understand what you're saying completely and absolutely refuse to acknowledge what you're saying because you're not speaking their language and you're not promoting their perfect Albert Einstein.
Mm.
And I've seen that so many times, it's ridiculous.
Like they get uncomfortable talking about anything that goes against their theories.
They literally think he's a god. He was a man that stole an equation from Henri Poincaré from, this is rumored, but when Henri Poincaré asked him to debate him on that very same solution, he wouldn't do it. Not only would he not do it, he left the country. Why? So I have issues when it comes to the way that they think of Albert Einstein being a god.
So do you think Albert Einstein was a scammer? Like
everybody else. No, I wouldn't say that. But
he knew what he was talking about?
He did, but there's also evidence that he wouldn't debate someone who came up with that very same equation 8 years prior or 10 years prior, whatever it was. He absolutely refused because according to the newspapers, he was nervous about it. Why? If you're the genius that came up with it, if you're the one that understands it, should you not want to debate it? I'll debate my system all day long to anybody because I've seen it. I've lived it. I've experienced it. You haven't. I get it. That's why I'm not harsh on anyone. You need to have the system in your hands to play with it, to experience what I have. You'd be saying the same thing. And I have all the confidence in the world saying that because I know it can be replicated. I've built 3 of the identical big coils that you've seen. One's buried, one's sitting with somebody, and the other one you guys see I experiment on. And they all work identical. Nothing has changed. But they're 3 of the identical coils. So that means it's replicable. Now I replicated it, so is it really replicable? Not until it gets into your hands and you guys start doing it yourselves. Then I can say fully it's replicated. But I fully believe that the system is what everybody needs.
Hey, what's up, Crypto?
Hey, Crypto.
Bernie!
Hi, Bernie.
So yeah, I think that I got some experimentation to do, and Nathan, when my book's done, I think you're gonna have a mention in it for sure.
Oh, thank you.
For sure.
Well, I'll tell you what, man, I've done a lot of the experiments, and I used to build generator things and try to get over Unity devices going. Back before I even started the Gravity Flyer, I was doing Gerard Morin and stuff like that.
Yeah.
Just a difference in understanding of how things are built.
Absolutely.
And completely changed my mind about everything when I did it. So I'm applying those things. I'm talking to you about it because I can see them because I did it.
Yep.
You know what I mean?
I do. Well, I've built almost every free energy device on YouTube, and 90% of them don't work. Right? But there are some that do, that slipped in amongst those that don't. But you have to experiment to find them. I built a alternator generator, didn't work. So I built one that has
I only built one and it worked.
Not only that, some of the tutorials are very crap. You know, some of the people explain it very poorly.
I only built the
and
beginning,
as a result, we have
worked.
people like that Murray character trying to replicate the rodent coil, not knowing what the heck he's doing.
I did a Jewel Thief too.
Yeah, we know your pulse motors are awesome, Mike. I do know that. Definitely. I've checked out your stuff.
It's the only thing I replicated, and it worked.
Well, when I was replicating the alternator generators, a single alternator, it doesn't work.
I took my time choosing, though. I didn't just jump on the first thing I saw.
Right.
I took like 2 years picking something out, and Bedini was the one.
Not
Mike,
me,
I was
man.
the same way. I went through the practical guide to free energy devices multiple times before I decided on a rodent coil.
Oh yeah, I have that book too. 2,600 patents. Yeah.
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 What edition is yours?
I mean, I was already an electrician. I've put in so many electrical networks. I'm like, I'm not going to pick something out until I'm sure, you know.
That's a good question. What edition it is? I'd have to look at my file.
Because I managed to grab the 2017 edition, which is the latest one I could find, and there's one more copy on YouTube. If you don't have it, I suggest grabbing it.
Yeah, I think that's the one right before. Yeah, you know what? I might have that one. I think it's 2,800 patents. That one.
Yeah, it's got some colored pictures in there too. It's a really great edition.
Yeah. No, I built them all because you know what? I wanted to see if they were full of shit or not.
Yeah, exactly.
Well, I listened to like all the builders, and the one that talked my language and was Bedini and what's his Bearden and what's the other guy's name? He was the one suggested low carbon steel.
Oh,
I forget his name.
Tip
Yeah,
of
but
my
they all,
tongue.
you know what I'm talking about, right?
Yeah, I think I know who you're talking about. Gray hair, short
Yeah.
glasses. Yeah.
He's got an unusual name, but anyway.
Yeah.
And,
No, those
and
guys
like
are
Ralph Ring and
Eric Dollard.
That's
Eric
it.
Dollard, yeah.
Yeah.
He has a lot of technical language going on there. And it's good to listen to Eric Dollard because he speaks in engineered terms.
Yeah.
Okay. And capacitive reactance, if you got a capacitor in the circuit, it's a load. It's going to be a load. An inductor is a load. A capacitor is a load. An inductive reactance, capacitive reactance. So those little things right there help you understand what's going on. Capacitors are loads, okay? Until they're charged, they're going to be a load.
You're right.
Look at that, guys. There's nothing safe in my garage. Watch.
That's yours?
Yeah.
The flame is literally dancing on the edge.
What's that? What is that?
That's a saw.
It's a saw. Watch. I play with high voltage a lot. So
yeah, because you're not got no amps to destroy that terminal, so it's not going to heat nothing up.
Oh, I set things on fire, bro. Every time. I can't help it. It's like it's running across there.
Nathan,
looks like it.
Fire.
Yeah.
In technical, our cells are all like whatever they are, less than half a volt. I don't know what it is. Each cell has like 0.2 volts or something of potential, or whatever, 0.002 or whatever it is. But you have billions of them, right? So in theory, if you could, put all your cells in series, you'd have that potential, buddy.
Yeah.
That's billions times 0.002 is like, in the kilovolts.
And technically, if you could put energy into every cell of your body and your brain was to oscillate.
That's the whole meditation thing, aligning your cells to be in series.
I think that I think we are made for anti-gravity. I think, honestly, our systems, the way that the human body is built, and I've studied it extensively. I mean, I'm no doctor, but I believe that we were built to fly. If anti-gravity works the way Nathan and I believe that our bodies humanly were built to fly. Now,
if you're correct on that, I'll be first in line for your class on flying.
It's an experiment I'd love to be able to accomplish, but you know what? We'll have to see.
I mean, we do hear about that in history. People like the Tibetan monks being able to levitate themselves under meditation.
Yeah, and technically speaking, in theory, if they were able to align up all their cells in series and connect their little miniature voltages together in series, they would be able to focus that voltage to an output somewhere into a high voltage potential, which would give you lift.
Have you guys seen this video? The transmutation video?
Yeah, this is awesome.
I haven't seen it.
This is Bernie all the way, man. Like, the
That's why I
absolute,
thought
Yeah,
of
that's interesting what he does there. I don't know. That's
yeah, he's creating this formula and he puts it on these things and he's making these capacitors, it looks like, and everything else. and changing
transistors.
the value in it. Yeah.
Are those like burnt out parts or what's going on there?
Those are transistors that he made for his speaker system. He was into high fidelity stereo equipment before he went to.
Oh, those are custom made transistors.
right. That's right. Yeah.
Hmm.
Okay,
Yeah.
so listen to what he says. I'll unmute it for you.
He was trying to make a material that had a natural switch to it.
John Testatika was a big fan of Walter Russell. So if you look at Walter Russell's chart, sort of looks like this. And then all the elements are in here.
Right. And this is very different from the periodic table that we're taught.
Right.
That's a crazy way of thinking.
So
It's awesome.
you see, in this cycle here, right, you might have Cu here, which is going to be copper,
Right.
right? And you might have gold Ag here.
Right.
So what's the difference between the two? Is a harmonic shift.
Right.
You see, it's a frequency shift because silver may be right here,
What is that?
Oh,
right here.
Yeah, I have a diagram to
Zinc
show you
may be
after
right
this.
here,
Right.
and lead may be right here. But if you look at Walter Russell's chart and you look at what it would take to move copper to gold, is a
A lot of
frequency
electrons.
shift back down to this level.
Yeah.
Well, it's the same potential.
So
obviously.
you can do something to this copper right here, this substrate. If you can do something to it by seeding a material on top of it,
Right.
right? And then you fire that in an oven, what happens is it's going to transmute
Hey, Ben, did you make
That
sure
level.
Crypto's got that link?
whatever's in here. It's going to transmute it to this material.
Yeah, I think I sent it
So
to
you
him.
Take this layer.
Let me double
out,
check.
That's funny because you
And
can
that
find
for
copper with
assay.
gold naturally.
That's what was in the material.
We're gonna be rich, boys. We're gonna be rich with this idea.
So see,
Right.
maybe Walter Russell isn't
So Walter
far
Russell was
off
saying that the tip of the sine wave
putting
is
the chart
is-
together
is-
the way he did.
Yeah.
is
but
That's
Dini
all
got
I
in
did
trouble
say.
two
for
elements, copper and gold.
There's the positive spin and the negative spin.
I sent it to him, but I'm gonna forward it to him
He
again.
called one a male and one a female. If you read his book,
All right.
you know, he called one plus and one minus.
You mean the elements? He called those elements. plus-
Yeah, well, he talked about life, about these two frequency shifts. You know, I think he had a drawing, something like this.
Yeah.
So I had to check it out. And I had to try it for myself, and I was thoroughly convinced
You know what this means?
after being
Ele-
booted out of the
that-
hi-fi industry with this
and-
stuff.
Elements that are female.
And
He got booted
Oh, it's
out
a
of the hi-fi industry
Here, I'm
for
gonna
trying to
share my
make
screen.
gold.
Check this out.
Yeah, he made it. He
No,
actually
I know. I saw that before. Yeah.
he got in
He did it with
trouble.
copper. What he's just showing there is that the copper and the gold are very close on the top of the sine wave. You know,
Yeah, he was taking copper pennies and turning them into
But-
blobs of gold and showing people on.
essentially what he's trying to say is their potential are not too different. Their voltage potential, you know, on the sine wave.
Okay, so check this out. This is from the plasmoid unification model, and he has all the elements arranged on his toroid. And he said it's not the exact truth, but it's a parable that gives us an idea of what's going on with the elements.
Yeah, but you can't go by this because because Malcolm Bendall works for the government and he's never going to release a full piece of information when it comes to transmutation. They would
He's
never
trying to
allow.
say if you give the copper a certain type of differential potential, it will shift over to this potential, the potential of gold, whatever the potential of gold is.
Bedini did it. He was turning copper freaking pennies into gold blobs. It got taken down.
If you knew the voltage reading of gold, which we do, then you could give that to copper and transmute it. Is kind of what he was saying.
So aren't the copper lines that run?
He used like chemicals too.
Like what if they amp them with a lot of voltage? You're telling me they could turn them in from copper to gold?
I'm not saying you need a lot of voltage. What I'm saying is he was showing the copper and the gold very close at the tip of the peak of the sine wave there. So let's say that's a 10-volt peak-to-peak sine wave totaling 20 volts, 10 on the positive, 10 on the negative. Let's say 20-volt peak-to-peak, sorry. And, on the 10-volt side, the positive peak was 10 volt. The copper was like at 9.5 and the gold was at like 9.8. So you don't need to create a huge potential differential to get copper over to gold. If gold is 9.5 and copper is 9.8, and you want to shift copper from 9.8 to 9.5, you give it a 9.5 voltage.
When Bedini was turning copper to gold, he was using a hydrogen torch, which was run by Brown's gas. Brown's gas is made by breaking water.
I hope we're wrong about this.
Between 4 liters. You use 4 liters of water, and the very first liter that you make of hydrogen is Brown's gas. He was using that on a copper penny and turning it to blobs of gold. It got taken off the internet immediately. I still have the video.
Okay, is this an experiment that's doable?
Yeah. But you have to make hydrogen first. You have to have a hydrogen torch.
He got this experiment from Walter Russell's theories of the elements and how they line up on the sine wave, which is not a bad theory. Okay, that's a good theory.
Do they sell hydrogen tanks?
There's a sine wave, a 360-degree circle in all energy cycles, and that's a sine wave. One sine wave is a 360-degree circle.
Hey, Gerald, we get in a lot of trouble for showing that video?
Yeah, we would.
So it's not a bad theory to say that all elements are on that one cycle of energy. That's not a bad theory at all. That's a very good one.
I'll find it in my
very concrete one, in fact.
Drive, Nathan.
Very hard to argue that one.
But it might take.
If you have an electrical mind, and energy, and thinking electricity, like you have a sine wave, like whatever the universe is putting out, whatever that sine wave is, it's a sine wave. And on that sine wave, there's a cycle of 360 degrees. So he was pointing out on that sine wave on that chart, Bedini, a sine wave, he was pointing out that Walter Russell was saying that all the elements are within on this sine wave. Gold is here, copper is there, silver is there. And he was also pointing out that gold and copper were at the top of the sine wave, very close to each other.
Which, by the way,
that means you wouldn't have to create a huge potential difference between the two.
If all of them are controlled by the frequency, right, then there's got to be a giant resonance chamber somewhere in the earth. It has to be there. If everything is controlled by the frequency, then it's going to have to be there.
Absolutely.
Is this going into the hollow earth theory?
With a giant piezoelectric crystal in the center that creates plasma and in a magnetic field.
Correct me if I'm wrong. Don't they find a lot of lead and copper with gold?
Okay, hold on. I have something for you guys. I'll find it real quick so you guys can check it out.
I'm gonna have to bail right away, Nathan. So right after that, I have to go.
Gotcha. Give me just a second.
Yeah,
I'll try to go as fast as I can.
I'm not rushing you, brother.
It was like one of the first things I put on my channel. So, and it's crude. So
no, we all have crude stuff. I'm a crude kind of guy.
Oh man.
Lately, McDonald's has been making some greasy burgers. Talk about crude.
But that's not real food, though.
Yeah, and the prices, the price increase for fast food has been ridiculous too.
Using this video. Oh, the Ankh. Oh, I
Mm.
can get into that.
Okay, so check this out. If you take this right here, right, the Egyptian cross.
Yeah.
Now, I'm gonna freak you out a little bit. Now they see things in dimensions when they they understand how this stuff works.
Yeah.
So when I show you this, just understand this. So if you take this and you flip one upside down, right? Now you put it over top of each other. Now you get what we have probably at the center of our Earth.
Do one better. Fold it in on each other. You now have a wormhole.
Yeah.
Wow.
So check this out. So
do you know that the Ankh is a motor? Whoa,
that's
what
a symbol, it's a symbol of resonance. Okay. Oh, this right here. Sorry.
The Ankh
That's
is
what
a
we're
motor.
looking at.
I think the swastika symbol is a magnet iron motor.
So I drew this one day
The Tibetan
after
symbol.
it. So hold on. Look. So what we got is the energy field, right?
Yep.
You have a cross in the center.
Yep.
So now you also have the crystals right there in a resonance chamber. And you have the vortex that goes down through the top and the bottom of the earth. And the center is the heated part, just like it would be when you do a magnetron.
Wow.
It looks like
So-
a.
Could be a water wheel too.
It looks like
You
a
know
brick.
what you just
But if
reminded
you
me
know
of?
about the V-gate motor and you look at the, I'm talking to someone in the chat. Sorry, go ahead.
I wonder if the Freemasons were meaning this when they said "as above, so below." Like I'm no Freemason, but I've heard that term so many times. And when you look at this, it's like perfect symmetry.
Yeah, it's as above, so below. It comes from the Emerald Tablet of Hermes Trismegistus. And
Yeah, that I know.
And it references there's an interconnectedness between all things and all phenomena in the universe. So I'm pretty sure it has something to do with that. What the Freemasons took from that, I don't know.
Well, the compass and square doesn't mean what people think it means. It has.
I
to
believe it's a symbol of vortex math or Sanskrit math.
Yep, absolutely, it is.
That was my theory, and I kind of put that in the Divine Science documentary where you kind of overlay the Masonic symbol with the VBM symbol, and you kind of see the
It
similarities.
looks like a core with a toroidal field around it.
Kind of.
Yeah. It's a toroidal
Yeah.
field on both sides, and you see
Like a piece of iron generating a toroidal field.
So I have to take off, but I want to touch on this really quick.
Or
The Ankh is also a motor, and
Like
you
the
can
iron's
spin it
resting horizontal.
clockwise, and you can spin it counterclockwise. So I kind of wonder if they use that to create some form of anti-gravity, or open some form of a portal.
Yeah,
Now we can
Stargate of
show-
some sort.
Yeah, my brain's blown, man.
looks like the sun's orbit in 1 year. You've got the summer and the winter processions, and
You
that's
can
how
see what looks like a quill strand in the middle.
Yeah, it's perfect symmetry all the way. It's
it also could look
Oh.
like a chromosome splitting too, like how chromosomes are when they do the split. That looks like that too in biology.
Well, you think of all the things you see
Never seen
around
that.
the world, it looks just like a regular cross. If you
I've never
take out
seen
the top and bottom circle, it
Well,
looks
that does look like that. You're right.
you're right.
so. It's every symbol you thought of. The affinity symbols in there,
Yeah.
Okay. And you see the scarab. It tells you that there's the what's it called on the outside? What's the field on the outside of the Earth?
Oh,
Magnetosphere.
yes.
It tells you that right there. So it's giving you a lot of information at once. It's also telling you the crystals right there. You see them at the bottom. That it's piezoelectricity that's causing.
What do you suppose the
resonance.
square parts are, the top and bottom?
The symbology in this is amazing.
What do you think those two square parts are at the top and bottom? What do you think those are?
I'm not sure. I see the vortex. When you see the little lines going like this, it's the vortex.
Yeah.
Horizontal or vertical?
So, like when I show you this, you see the vortex now. I colored it in blue.
Yep.
It's running horizontal.
And energy flows in water and in magma. Because
I don't see the vortex. I see.
You see it in blue. It's in blue. It's running straight to the center. It goes all the way top to bottom.
Yeah. Top to bottom.
Two vortexes going into each other at the center.
There seems to be two of them, yeah.
So, like I was saying, water's energy flow, which is energy. Magma's energy flow, which is energy.
It's like
magma dried is basalt. Basalt is magnetic. Now you start to understand the flows inside the earth.
Well, I know in schematics, they use a cross to indicate away from you and a dot to indicate towards you. So it looks like a cross indicating away.
Is Bernie in the background?
And there he is. Let's do it. What's up, Bernie?
Hey, Bernie.
Bernie!
Oh, Bernie.
Hi, Bernie.
Oh, hello. How's it going? I'm enjoying this. This is I like it. There's something to it.
It's kind of a trip how it comes together.
Yeah.
Did somebody draw that, or where's it? Where's the image from?
Why couldn't you show up sooner, Bernie?
I was sleeping. Okay.
Oh, okay. That's a good enough answer.
I don't know. Is it at 8:00 p.m.? Like,
what, were you up late last night, brother, or what?
A little bit, but then I was just, I don't know. I was tired.
Yeah. Afternoon nap that took too long. I hear that.
Yeah, exactly. I'd gotten up and then just fell back asleep. But now it looks like there might be a tornado coming, and got the hail warning on the phone. Hopefully no tornadoes, but I guess that'd be a good example of a Taurus, right?
Yeah, but I don't think you can capture it, brother.
There's no tornadoes in Canada, man.
Oh, yeah, there's lots.
In Canada?
Oh, yeah.
We have lots of tornadoes.
Never knew that.
Yep.
Thought it was too cold for that.
When I was
not in the winter, but we still do have 2 months of summer. So
in the summer it happens?
In the spring too. When I was 13, my dad brought me to where there was a tornado and showed us a 2x4 go right through a telephone pole. It was really neat.
That's fun.
Full 2x4. It was halfway through this telephone pole, and nothing was broken, but it was right through it.
So that's interesting that you mentioned that, because I think it was in the Practical Guide to Free Energy Devices, it mentions that, and it shows a picture of a piece of wood through a tree or something, and it mentions that this is some form of natural transmutation, like it's softening the material or something.
Kind of like the Hutchinson effect.
Right.
Never thought of it that way. I always thought it was just like super speed pressure, and it just.
That's what I thought, but according to the guide,
makes sense now that you're
according
saying
to the good book.
So the vortex then taking it apart, and part of that transmutation, and then that explains the Martin Fleischmann Memorial Project, the wind hex, and how that's the vortex disassembling the particles.
Yeah, how it can go straight through the solid material and not even like, it should split the wood if it does that. You know what I mean?
Yeah.
I have a question about
nice piece.
Effect. Like, he made things disappear. Where do they go? Like, where do they go?
He doesn't know, I don't think.
Maybe they didn't disappear. They just moved so fast you couldn't see it.
No.
I know there is, when he sent his video clips to the government, they sent him back and said, do you realize if you pause it at certain times in certain frames, your items are disappearing?
Yeah. Like I think
really?
like a bowling.
Yeah. I was planning on scrubbing his video footage at some point and trying to find that, but
who's Tesla's footage?
Hutchinson. Yeah.
Hutchinson, yeah.
Okay, guys, I hate to bow out. Bernie, sorry I couldn't spend more time yakking at your brother, but I got to get going. I got to work tomorrow. So
thank
have a good one, Gerald.
Conversation, you guys. It's been amazing.
Yeah.
This was awesome.
Yeah, thank you.
And I'm going to do some experiments and get back to you on that, Nathan.
Hey, Joe, real quick before you leave, I just want to show you something.
Yeah.
You've ever seen this?
Nope.
Okay.
Yep.
I really haven't.
This is the Black Pyramidium in Egyptian Museum.
Looks like something the Freemasons.
Really?
So let me point some things out to you. You got
Okay.
the battery on the bottom, that's DC. You got the feathers, which symbolizes the static electricity. You got the circle in the center with the two snakes as a high voltage hiss. It's anti-gravity right there in front of you. If you can read it.
It's right there.
Wow.
Look at the two eyes that are sitting beneath the center of the wings, and the circle in the center of the wings, and the circle below that. It's exactly the picture you just showed almost.
Yeah. It's
That's
right in front of us if you know how to read it.
Yep. You're
Yeah.
absolutely right.
Wow.
All right, guys. Thank you very much. We'll talk to you again soon.
Right on,
Thanks,
Gerald.
Gerald.
Have a good night.
Have a good one, guys.
Good night.
So you sparked my interest with transmutations.
Oh yeah. I put that
Ooh.
back on for you, man. That guy, he's got some cool stuff, man. It just reminded me of what you were doing.
What Bedini? What was
definitely
doing with
does.
the iron or whatever it was? Iron particles of iron and something else. He was using the stuff they used to make batteries, right?
He was making stuff for sound. He did sound equipment before he did all this other stuff.
He was mixing it with iron, right, to get that stuff to climb up the iron rod and coalesce into his natural switching device or piezoelectric material of some kind.
Yeah, so why, as Gerald was saying with the hydrogen and how it's necessary, that's why the electrolysis makes it so possible, is that you're literally producing that atomic hydrogen as well as several isotopes of hydrogen while you're doing it. So it's providing it for you.
Nice.
Interesting.
We knew
There's
you
the
had the
primary.
answer, Bernie.
Right.
got
And
it
I have
horizontal,
turned copper to gold a
vertically
couple times.
drawn
It
out.
just the process, it reverted back after like 6 months.
Really?
So
I think I mentioned-
I'm pretty sure it's because I didn't have like the frequency to be putting it in, and I just need that right resonant frequency to like solidify it into that state.
Huh.
I think somebody mentioned once that there's a theory that hydrogen isn't even an element.
Yeah, well, in Walter Russell's charts, it's that it breaks down into like 8 or 12 more additional subparticle elements.
Oh, so that's what it is. It's we haven't fully defined hydrogen then, maybe.
Exactly. And even now they're making claims that they're now discovering new particles out of hydrogen that are different isotopes of it.
Oh, really?
Yeah. I'll try to find the latest article on that. But
Yeah,
let's
bring it
listen to
up.
some
Like
Bendini.
isotopes. That's a
They always have
Subject
interesting
always
ways
gets
of like coming out with the new science that we've already been researching for decades that have been suppressed in like different ways to make it seem like it's not that it's new and not like been out there for a while.
Do you guys think the science suppression is supposed to be scaled to the generations that are out there? Because if think about it, if they disclose everything, then there's nothing else to discover, and the future generations won't have anything to do anymore. So what if
No, because then it's like it means that there's nothing for us to do right now by doing that.
that's why we're hated, because we're trying to expose things that they are holding for the future, maybe.
Yeah. You know, my take on that is that I think the closer we look at things, the more questions we're gonna have. Like, right? The more answers we find, the more questions it's just gonna raise. Like, I think the universe is infinitely or maybe infinitely complex to the point where we could just zoom in and find smaller and smaller particles or strings or whatever.
Just thought.
But yeah, I think we're always gonna have
science
questions.
is always science is never consolidated. It's never going to be consolidated because it's always new discoveries going on. It's an endless field of discovery. That's why it's called science.
Yeah, but haven't you noticed some discoveries they shadow ban it completely?
Yeah.
So they don't want some sciences to come out into public. Why? I mean, it just makes you think why. The only logical explanation to me, it's like if they disclose everything, then they can't control the whole theory of education systems.
Oh, in that respect, yes, you're absolutely right. They lose their ability to control the population for sure.
They lose the power. Like if you understand, if everything's already discovered, doesn't give momentum to young generations to do anything anymore.
Not to mention the fact that people are already really distrusting of our governments, and this will add just the straw on the camel's back in terms of people's distrust in the government. Like, oh, you've been hiding this for decades. We have already don't trust you.
Like how the Tesla cars, that science has been there for 50 years, but they just released it. Like in the last decade. So it's like they do hold things. Like in time series, they don't. Like we could live without oil.
I do think I can say with confidence that people like Elon Musk don't know about these technologies. He's not. He doesn't seem like he's in the know. If he really wants to save the world, he's looking to the wrong technology, in my opinion. But if he knew about 0 point energy, I don't think he would be looking into rockets.
I don't agree with that. I think he knows it. He just knows he can't show it.
I'm not so sure about that.
He has all the contracts in the world to get there.
But
he's little satellites around the world, man.
He's a little unpredictable when it comes to public.
What's the deal with the Starlink?
And I don't think the powers that be would trust that information with somebody so unpredictable.
I don't think he is unpredictable, to be honest with you. I think he's very predictable. It just looks on the outside like he is. I don't think he's that way at all.
Yeah. What do you think about the recent statements that he's creating auras because his rockets are punching holes into the ionosphere or something like that, they're saying?
He's creating auroras?
Yeah. Apparently there's Tesla or SpaceX auroras now around where he's launching, and that it's punching holes into the ionosphere.
All I know is he punched a hole.
But then why wasn't
Twitter.
NASA's rockets doing that, or anyone else's rockets, and now all of a sudden it's a thing?
Yeah, no kidding.
Government, and he's a private, and so like you can't attack the government.
Good point, Lulu.
Private, sector, it's easy.
Government knows how to conceal better.
Kind of makes me wonder about that.
Yeah, like kind of. Are you saying the soundstage, the whole thing?
The government can conceal better than a private would.
You can't conceal an aura in the sky, though.
Yeah, but the government's got their fingertips on the media. They can shut everybody up.
Oh, that's true. That's true.
With a phone call.
Yeah, they definitely they have.
I'm not kidding. With a freaking phone call, one number.
Every media outlet.
They got it set up like that.
What's it called? Project Mockingbird or something like that?
Every single government, no matter which one you're under, they got the media under wrap. And,
this is very true.
If it's something that they don't want the grand public to see.
Oh yeah, there's somebody in every media outlet ready to kill a story if they have to.
You can get it out there with your smartphones as quickly as you can, live it and all that. They can run algorithms to find it and remove it.
Hey, I got a question for you, Bernie. You ever take that paste that's at the bottom of the jar of the material and put it in the center of a capacitor to check the K value?
I have yet to. I've wanted to. Do you want me to send you some?
There's a time limit.
That'd be cool.
Do that.
Oh man, I'll just light it up. We'll see what it does. Because that stuff is like pure. It's like you took out all the other stuff out of there, right? So if there's no little percentiles messing with you, this stuff is like right there.
Yeah. I'll get you some aluminum, some copper, and some zinc to try out.
Right on, man. Absolutely. I'll put it right up on my channel as soon as I do it, man. We'll just make a little form out of it, make sure we dry it out a little bit, and then we'll put in some wax paper in there, and then we'll see what it does, man.
Exactly. That's exactly what I've been wanting to do. Okay, give me about a month's time because I'm in the process of just washing them right now to get all the salt out and then to dry it, and
That takes a
I
lot
will
of work.
send her away.
Nice. It'll be.
You gotta wait 24 hours each rinse, huh?
Yep.
I'll have to make a positive and negative mold out of something, just like you would like a crystal. Push it in there with a little bit of force, and then get the electrical field to go through it. Just see what it does.
Right, exactly. There's so many experiments needing to happen with it to actually see what this stuff really does.
Well, yeah, because if you get rid of the impurities, is it stronger or is it weaker without the impurities? You know what I mean? I don't think we got a whole lot of answers to that.
No, there's none. Like David Hudson's work was really all that there was on this stuff, and then
I have a theory on how that works. When you electrolyze a metal, let's say zinc, and it powderizes down to the ground into a pile of powder, and then you keep it running and it starts climbing back up. The stuff that climbs back up is probably the purest stuff.
Yeah, because some does get charged and like float to the top, and then some stays in the middle.
I could be wrong.
Some goes to the bottom, right? And
I think the stuff that climbs back up is being, going back upwards through the flow, the inverse flow, negative flow, or whatever. Positive, negative flow, I think when your positive flow is breaking it down and the negative flow is purifying it.
It'd be interesting to take different levels and do different readings on the same material.
It positively flows through its own two potentials first. To balance out the two potentials, it's going to have one potential move to the other until it's balanced. And that's going to be either the zinc or the other material is going to move, the potential. In the process of doing that, it breaks down to its elemental state, including any impurities that are in there, should fall to the bottom. But whatever flows going in the opposite direction will carry up, in my opinion, the purest of the zinc will go upwards and the impurities will go downwards.
Well, doesn't it matter about its weight?
The impurities will go with the positive flow and the purities will go with the negative flow.
Yeah, but I'm saying once you break them down into individual parts, it really depends on the weight of the item that you're breaking down on each level of each one. So,
that's the whole other thing. If you've done electrolysis between two metals, you'll see the zinc turns into a pile of powder in the liquid jar. It just turns from a metal plate to nothing, to a pile of powder. But if
that may work for the zinc, but how does it work for the gold? Is gold heavier?
Whatever other metal you use, I don't know what you're using. It could be anything else to create the differential and potential flow. But the zinc itself will break down. You could use a piece of carbon or a piece of copper or whatever on the other potential. But on the side that the zinc is resting in that jar, the white powder forms at the bottom. And if there's going to be a plasma flow established, even if you don't see any metal of zinc connecting to the powder below it, and it looks isolated, well, there is nanoparticles climbing up. You don't see them, but it builds upwards after it decomposes to the ground, and the electrolysis keeps running. Some particles start heading up.
Yeah.
You've never seen that, Bernie?
Oh yeah, all the time.
That's what I'm talking about. Those particles, they're probably the purest form of the zinc or whatever, if it's zinc that you're breaking down. I think the stuff going up is the most purest stuff.
I think I've got a picture demonstrating what you're talking about here.
Like the bottom of the powder pile that is formed is probably all the impurities down there. You just take the top of the powder off and rinse it a bunch of times.
So like in this jar, you can see there's like the bottom stuff, and like this is being rinsed once, right? And then there's a little exclusion zone at the top, and then you have your top material. And then in the middle is usually an exclusion zone. It's just separating. Some's going back up, some's going back down, and then this area will clear, and then you'll have your top cloud and your bottom cloud.
Oh, okay. So there was a guy that was I forgot his name. He is on YouTube. I don't know if he's still on YouTube, but he was saying that he was making enormous. He was saying that the stuff at the water at the top is the purest stuff.
Yeah, but
this
I don't know that it is, because water has a density to it and there's a weight to each particle. So I don't
Well,
think
the heavy metals is the heavy part.
apparently
They
in
take it
this
down.
state it creates positive and negative water, and then the positive and negative particles separate with it. So it's like they're
Right.
all charged electrically.
And usually the toxic stuff has got heavy metals. It's heavy particles. So they fall down. And the stuff that's going to the top is doing that through electrolysis that's in the liquid solution.
So here's a copper pipe that I had as an anode, and look at like these weird things that grew off of it.
Yeah, that's probably poisonous if it's copper pipe.
Oh God, of course. I touched this with gloves, and it's just an experiment. But like, what the heck are these things? They look like an eyeball.
They look
I
like
don't,
barnacles.
right? Yeah.
Yeah.
It's calcification. Scales of heavy particles, heavy metals, heavy scaling deposits. Copper's not pure, man. Copper's got lead and stuff in it. It's not pure. It's pretty high quality, 98%, 99% copper, but the rest is, impurities.
Here's some aluminum foil turning into the red state. It
Oh,
becomes
it's so cool.
Bernie, how did that copper turn back into copper after you turned it into gold? That's like, I'm not understanding. How did you know it was gold?
well, it just looks like gold. It was still in the jar, and it looked like pure gold for like 6 months straight, golden color and shiny, and then it slowly reverted back to being the color of copper.
Okay.
Oh, it's frozen.
You didn't take it out of the jar the whole time?
No.
Did some of the other elements go back into it to reform the other material?
Could have been.
What is
Here I'm just showing the natural swirls that happen in this stuff.
can you, like, if you do the
It's not
experiment,
showing up.
distill the gold out and actually test if it's real
It's not
gold?
loaded. Oh, I think I'm having bandwidth problems as the hailstorm has come in.
Wow.
It's the second time you got hail in like, what, a week or two?
Yeah, it's just that time of year.
Canada sounds more active than Florida, weather-wise.
Dude, it's still like 90 degrees outside here in California.
I
That's
believe
pretty
that.
hot for California.
Mike, you're in Miami, right?
Yeah.
You should go to the beach. It's turtle season. All the eggs are hatching, all along the Atlantic coast.
Yeah, I've seen them a dozen times already.
You have? Okay.
That's pretty
Yeah,
cool.
I've done it.
I'd like
I've done
to
at
see
least
that.
10,000 miles of Everglades in 10 years, or the 20. I don't.
Why are you filming that? You got to be putting that on your YouTube, Mike.
Oh, it was before I even had a camera or anything. I was in the Boy
We'll
Scouts.
get back to it. We need to see turtles.
Did 10 years in the Scouts. We went out twice a month, 3 days each time. Did at least 25 miles hiking, 30.
Like I met so many great people.
That's a lot for 3 days. You 10 miles
That
a day
is.
is a lot with your gear. That's a lot. You don't want to go over 10 miles a day with your gear.
In the
So 3 days, 2 nights in one day. It was like 20 to 30 miles, depending on if we were out there 2 or 3 days. We did at least 10 miles a day hiking with gear every time we went out. And we wouldn't just stay there all weekend. We'd move another 10 miles. Yeah. Troop 65. Look them up. They were the most active troop in the country for 25 years out of Miami Beach, Florida. I was in it for 10 of those 25 years.
Oh, she's coming down
So
strong.
I've seen it all in the as far as the Everglades goes. Never seen a panther though. Some of the people I was with in the scouts, they saw one cross the road once. I missed it.
Really? Those
We were driving
big
in
cats
at night,
scary.
crossed right in front of our van, but I wasn't looking. I didn't see it, but everybody else did, and I was like, "Damn it!" That Florida panther. They said it was a dark color, like not light brown, like the mountain lions look.
Okay, I've got a video I
More
gotta
like a
show you
leopard.
guys.
All right.
But you're gonna have to like put me on full screen, I guess.
Okay, hold on.
Hear that static electricity when I reach my hand out over the edge. Wish I could shoot lightning bolts out of a finger.
You see like the charges flashing by as he's doing that?
Oh yeah, what the hell's going on there? Those little lights.
It's literally standing on the cliff of the Grand Canyon.
Absolutely. Look at the hair. Ooh, man, that just shocked me.
That's not hail or like snow or something.
Probably not safe to be up here, but here we are.
Some
I paid $20
rain,
to get in. I'm
and
gonna
then
get
some
my-
is electrical charge when he sticks his hand out.
the hair of my arm
Wow.
Oh,
standing up.
Is that coming from the atmosphere?
I'm not gonna see too much. I think we'll call it good there.
he's on the edge too. There's like a static
So
charge.
we'll
probably on
restart
that surface.
this short in 1 second.
Yo, check this
So yeah,
out.
look at that.
Hear that? That static electricity when I reach my hand out over the edge.
That's something.
Wish I could shoot lightning bolts out of a finger.
It's dry out there, huh?
It's just wild. Crazy getting up at the top of a mountain in a thunderstorm. But check out that view. That is awesome. Absolutely beautiful out here. And the rain is kind of going sideways and up.
You can see little things coming off his finger, dude.
Man, that shocked me. Ouch.
Just got shocked from the cloud or from the moisture.
Probably not safe to be.
I would have been. I'd be ducking, bro. I mean, I'd be looking up for lightning to come down.
Right? So it's
If
like,
that's happening to you, then the lightning's heading your way. You better get down somewhere, get out of there.
but
you're in a
is
great
that
spot
the
to get hit by
state
lightning.
of
Exactly.
like that's like a plasma state of water, and is like that like the brown gas or the HHO in a cloud state, right? Like
I had that feeling once hiking at night into the glades
Check this
and
out.
weather
that's
like
what I'm
similar.
wondering. Put back to regular size. Sorry.
Okay, sorry. You know what? I've seen that before, Bernie.
Was
Hold
it a
on.
lot? Like
No. I'll show you. Let me just remove this one right here. I seen that once when Alexi did this thing in the red. Okay,
Getting
So
struck by
you'll-
lightning, it's not that uncommon.
you'll see the free electron just flying. Watch. Give me 1 second. Let me go back to it. Let's play it.
oh yeah, you can see him a little bit.
It'll look like he's smoking from the bottom right side. I think it comes up. You can see a little bit in there. There's a plume that comes there. There it starts to
Yeah.
go.
Right. And what I've noticed too is in a lot of like, especially in like the Bosnian pyramid caves, when they're walking through, that they also have the same sort of thing. And then also around like Luxor in Egypt and around the pyramids at night, they also get those same like charged little flashes flying around everywhere.
Yeah, it's
Evos.
like
Yeah, they're Evos. Those are Evos.
right now you can see it. Now it's starting to
Yep.
go. You see him flying everywhere.
Yep,
That's a trip, isn't it?
it is.
What's that in the center? That red looking thing.
Oh, in the center is his gravity flyer. He's turning it on and he's filling up the room full of
I don't see
static
it.
electricity.
Yep.
I don't see.
That's
Right,
what's
it's all
going on.
static electricity.
Is it invisible? I don't see any flyer there.
Ionized. I do.
There's the little particles that go flying around over there.
Like dust particles, but really fast ones.
Yeah, it looks like that, but it's
Looks like a
right
red-
before
red
you get
arc
to
or
the
something.
lift is when it shows up.
Right,
It's
so
like
it's
that-
like you're super saturating the room with those ionized particles and static charge, and then as soon as it's filled, that's when you're able to hit it.
Yeah. This is crazy. I saw your video and it looked just the same thing was going on. I only saw those things, man, when I get a real bad hangover. You're drinking too much. The next morning, your eyes are bugging out. And you see these little light flashes everywhere. Yeah, that's when I usually see those things.
Oh, so then you're saying you got to be hungover when you do your experiments next.
I don't know if that would help or hurt. I'd probably
Full of
get
both.
hurt.
Full of both, probably.
Yeah. Wakes me back up. Oh.
I posted a couple of videos in the private chat. If you guys want to check out quickly, just get your opinions on them.
Okay, I'm looking real quick. I don't see them yet. Is it in your private chat? So you're gonna have to show them.
Hold on, let me repost. It should be in your private chat.
I'm at the bottom of the posting on the screen. I'll say, let me see if you put it in private. Okay, hold
Yeah,
on.
but in private.
There we go. Oh, I just clicked on it. Oh, hopefully I didn't turn nothing off. All right, so hang on. Now I know what I'm looking for.
3 different topics, 3 different videos. All very cool.
One of them looks like a V-gate.
This
motor.
one?
Yeah, this one.
That looks like a V-gate motor. That's the
So-
V-gate system, Bernie. The
Okay.
letter V, V-gate motor. Research that. This is what you're looking at. So that's the V-gate motor, and he closes the V with the 2 sides,
Yeah.
and it does work.
So
You
you
just need to build it. It's a lot
build it
work.
accurately, and then it will work.
Yeah, but you do need a lever to remove the magnetic field temporarily in one part of the spin, like a reed switch or something kind of thing.
So what is he supposed to do? Is he going to spin it? Is that what he's doing?
Yeah, he's gonna close it.
It's a magnet motor that when it turns over a certain part, in the V-gate system, the magnetic bar is removed, and you just use a
Yeah,
lever.
so as soon as he
use a lever
closes this
to do
thing, then
that.
it just spins like crazy.
Oh, nice.
So he's going
Right.
to show the same on this one.
And to remove the magnetic bar at the right time to keep the spin going, there's a lever to do that, a system for that. If you look at the V-gate system, you'll see what I'm talking about. And you can modify that system in many ways with magnets. And you just align the magnets in a 45-degree angle in like a V shape. And when you get to the tip of the V, you have to have a lever or some kind of way to remove the magnetic bar in that section to get it to keep pulsing around.
And he must be explaining a lot.
Yeah,
It's in
it's all in
Spanish.
Spanish, I think.
Click on subtitles.
Oh, here you go. Looks like he's doing something.
Oh, there we go. Is it going to close? Yep. Closing. Maybe just teasing us.
Okay, so at the top there, when the magnets pass, they push apart the
There we
two
go.
pieces slightly to keep it.
Oh, man, it
rotating.
goes fast, too. Look at that.
Right? I think that's legit. I think that looks pretty legit. How would you fake that video?
With an air jet.
Oh, air jet. Yeah, I guess so. Yeah. That's good call. But you think it's real, Mike?
Well, it is. The V-gate motors work, yes, but you need a small pulse of energy or something like that, or like yes, you can do it with magnets, yes.
Huh.
But they had to be in a 45-degree angle, so the field is building and building, and then all of a sudden it's canceled because when it reaches the reset point of the weakest to the strongest part of the field, and then it breaks, kind of thing.
So it loses.
It's hard to explain it. It's more like bring up a V-gate motor on YouTube. Just look them up. V-gate system, the V-gate motor. Like bring up they got animations of it all over the place.
Okay.
Let me see
Well,
if I
I'm
can
trying
find
not to get nailed for copyright.
Copyrights, yeah.
No, they're all like.
I put a Bernie stuff because he's seen it before. He knows if it is or not. So let's see. Give me 1 second, guys.
I can find one.
So I guess with an air jet would be the one way you could
YouTube
fake
has a
it.
bunch.
We're just gonna have to make it to see if it works or not.
I could tell it's a V-gate motor because you could see the magnets have an angle like a V.
Yeah, that's right. Because on the strip, yeah, it does turn into a giant
Tons
V.
of videos on this motor, and they do work. Which you'll have to pay attention to the relay there where it removes the bar. And you'll see what I'm talking about. Let me see. Here's a good one. Wait, what's this? Oh, Pugal's Tech. You ever heard of him?
Which one?
Pugal's Tech. Let me send the link. Hold on.
Maybe.
There you go. You got to see that. Subscribe to him, man. He's got all kinds of like brushless DC brushless motor designs and all kinds of arrays of motors and DC, mostly DC and some AC, and he's explaining the V-gate system too. Everything he does is very good.
This Russell right here says the Russell Museum. Is that what one you're looking at?
Oh, that was another one I was going to show, but I guess play Mike's link first related to what we were just looking at.
If you go to like 5 minutes, you can see the schematic.
I don't have it in the thing yet.
Not in the private chat?
Where at? Okay. There it is. Okay. Sorry. That's my fault.
5 minutes and 35 seconds.
Okay.
And he speaks English. So
this one?
He's from, I think he's Pakistani or something. Yeah.
So that one's in a V?
Yeah. You see the V. Now go to 5 minutes and 35 seconds. That's where the diagram that he draws out and he explains everything very well.
Yeah, shows the north-south. Yeah, see that? Yeah, that V. There we go.
You can unmute the audio. I don't think he's gonna.
Well, 90% of the time, it nail me for the audio.
Yeah.
Really?
Exactly. Oh, yeah. Big time. Yeah. But yeah, so it's showing the north on one side, south on the other in that V shape.
Okay, you see the bar in the middle where the wide V and the narrow V meet? Go back a little bit so you can see the schematic.
Okay, give me a second.
Yeah, it's
There's a schematic right there.
thing. Okay, now pause it. You see the bar in the middle? The red and blue?
Yeah.
That's a bar magnet. So that's the moving part. And as the red on the right side, you see the little dots in blue?
Yeah.
On the top?
I'm seeing it. Go ahead.
Yeah.
And the red dots on the bottom? And you see how the blue dots are connected to the red? And the red dots are connected to the blue, so they're going to pull. So as you get down, as you go move that bar to the left, the pull gets greater and greater.
All right, well, let's see what he does.
But when you get to the apex of the pull, all the way to the left there, where the two dots are closest together, you should just unmute it. But yeah,
Copyright strike. Then it copyright strikes, man. They love nailing for this stuff because they're like screw free energy.
Right. And so when it gets to the apex, when the bar magnet gets all the way to the left to the apex of the triangle, you have to move it a little bit away from the magnets,
Okay, so
and
let's
then bring
give
it back again to the next triangle, but not the apex part, the wide angle part. And so you can see the magnet on the side there, how it wobbles a little bit, and plus they're magnets themselves, and they roll. That's slick. Yeah, it's smart. Where his left hand is, that thing resting vertical,
Yeah.
that is the trigger, and also the driver. So if you play it slowly, when the magnet that's on his left hand, that's a bunch of magnets. And it's basically a bar magnet. And if you see how it wobbles to the left towards his finger as it gets close to the apex of the triangle on the wheel, well, that's because you need it to move away. Otherwise, if it didn't have that wobble, the wheel would stop. That's the best way I could explain it to you. It's like other motors, they put a lever to push the bar magnet away when the wheel spins to that location. In other designs, they have a magnet that's able to wobble, and you don't have to have a lever pushing it away. You just need to push it away temporarily, right at the apex of the V array of the north and south magnets
Put it
on
on
the
a
wheel.
spring, like a
And
small.
then it keeps spinning. That's the whole operation there. So yeah, it works. I built one myself, and I didn't finish it, but I used my hand to move the magnet away and close. And you can use your hand to do it, to bring the magnet close to it and move the magnet away from it at the right time, and bring your hand back to it right away, and it'll keep spinning.
Is there a specific angle or degrees that you have to have the V at?
Yeah, I believe
45,
so.
45 or 20, whatever.
45.
Not really, because as long as it comes to a peak at apex, then at the peak, and then that would be the center of the bar magnet where the fields cancel, I think, or something like that. But whatever happens at that point, if you don't move the bar magnet away, the wheel will stop spinning. That's all I can tell you. So you need it to wobble. See how it wobbles a little bit? And it wobbles right where it gets, right when the wheel moves through the horizontal to the vertical standing magnet. You can kind of imagine that the V part, the tip of the V, is right at that point where you see it wobble when the tip of the V hits that section, when it turns right next to the vertical magnet. And the tip of the V is facing the vertical magnet. That's when the vertical magnet wobbles away a little bit, because the force there is such that it's going to push. And if that vertical magnet is stationary and it can't wobble, then it's going to push on your wheel instead and stop the wheel. So in typical V-gate designs, they have a lever on the wheel to push the bar magnet away slightly at that point, so it doesn't break the wheel. And then the lever is just a temporary lever, and the bar magnet comes back again close to the wheel for the rest of the V.
Is there a bar magnet on the inside of the white cylinder?
No, the white cylinder just has a V-shaped array of magnets facing out. One line is north, the other line is south. The line that is north is being attracted to the bar magnet section that is south, and the line that is south is being attracted to the bar section that is north. It's an attraction. But the attraction ends at the tip of the V.
And that's why it wobbles.
And it becomes a repulsion, I think.
Cool.
Because at the tip of the V, you also have the wide section of the next V, if you can see in the image there.
Yeah.
And that is a kind of repulsion force and a connection force too, once you get over that hoop there of connecting from one V to the next.
The Evo Lab says it's fake. You see that?
No, it's not, because I built one, and I told you I moved the bar magnet by hand, and it worked. You just need to be able to move the bar magnet. You can't have it stationary. It has to wobble, or it has to be moved.
So you have to have a little ticker thing designed into
Exactly.
it to move.
This is not that design of a motor. This is even better. he created a wobble system where it slightly moves just enough. And that's why it's more
That's
efficient.
100% right, Mike. The key aspect is that you have to have that other that small movement in it to
In
bring it
between
up
the
back.
peak of the V, the tip of the V, and the wide section of the next V, there is a push-pull effect that will create a brake on your system if your bar magnet is stationary. The bar magnet again is the vertical item you see there on his left hand pointing. That's a bar magnet. The north is, let's say the north is at the top and the south is at the bottom. And if you see the V-shaped magnets, the top line of V's would be south line facing out. So the south would pull to that north on that very bar magnet resting horizontal, vertical. And the bottom line of magnets on that wheel are facing north out. So if the bar magnet has the south at the bottom, then that's also going to be a pull force. And if that bar magnet is stationary and the wheel is stationary, and you have a pull force in a V direction, the pull force is gradual. It's not, I don't know how to explain it. You just have to visualize that to understand it, or build one. And you don't have to complete it. Just use your hand to move the bar magnet. And you move the bar magnet away when you get to the tip of the V. And then you bring it back as soon as that tip passes. And it keeps rolling. I'm telling you, I've done this myself. So, I know it works. One day I might pursue it. I don't think it's got a lot of torque unless you have really strong magnets. And those are really a pain in the ass to work with. So I built mine with little miniature, tiny little magnets on a piece of PVC, just like you did in the video.
So on this one right here, we're doing a water cell.
Yeah, a hybrid water cell, and this I really want to try to replicate because
drop the PVC in water. You don't even need a bearing. Just use water. It floats.
Okay.
It's as simple as 2 jars, apparently, a connection to your alternator, and one's a splitter jar, one, I believe, I forget what electrolyte they're using, but yeah, can you turn on closed captions and then we'll get what they're saying without getting the stoppy right?
I mean, with the V-gate motor, you're going to need really strong magnets to get anywhere,
Got a big pickle jar.
Right? Just 2 big pickle jars, apparently, and water with your electrolyte, your metal plate for your electrolysis device.
With electrolysis, you can break the hydrogen off from the oxygen of the water all day long. Yeah. The better your fuel cell is, the more efficient you do that with less energy,
And apparently in here he's saying with a carburetor, you can just feed it directly into the fuel intake with the gasoline, and it works fine.
Bernie, if you're making all these, metals, you ever try, making platinum? Because that's what they make fuel cells out of. Platinum. The platinum is the most efficient way because you need very little energy to create the electrolysis when you're using platinum.
Okay.
So you can cut it to the alternator.
You can coat electrodes with platinum.
And then there's the spitter jar.
But platinum's not cheap, bro. That stuff is.
Yeah, it ain't cheap for show.
But what if you knew how to, mine it out of mountain rock somehow, or get it extracted somehow,
So is it just gas going in this one now?
Yeah. Yeah.
If you can get the platinum out of general mountain stone, and then you have something to make a really highly efficient hydrogen generator with low voltage. I mean, you could use a platinum probe just to break down all your other metals with your electrolysis experiments.
Here you go. He's got his tube hooked up, so he's got gas being built in one, going to the other.
He's using stainless steel, which is galvanized with chromium, Okay. So that's kind of why it works good. The chromium is a good conductor. It also protects the steel from oxidizing.
So it doesn't replace the gasoline; it works on top of it, just as in the air, right?
You got it.
Yeah, he's breaking up the water into the gases of mostly hydrogen, right?
So you're injecting it in with gasoline, so it's
into the air take manifold, the carburetor.
It's a hybrid.
How does the engine know to change from gasoline to the gases?
It's not fuel injection; it's carburetor.
Well, I understand that. The carburetor sucks in and dumps gas directly into the intake. So it's not vapor that's going in there. It's liquid. Is it changing into vapor?
No, it's vapor.
Yeah, it's straight vapor.
Yeah.
See, no, I'm asking, is the gas turning into vapor gasoline? And
no,
this is vapor
it turns into hydrogen from water. The water vapor that's mostly
I know what
hydrogen.
that is.
He gets that. He's saying, how is it mixing with the gasoline fuel?
Inside the carburetor with the air. When the carburetor takes the gasoline and sprays it into the chamber, it's also mixing the air from the outside. If you send that hydrogen in that air, that's how it mixes.
Oh, that's the key. Okay, that makes sense now.
Okay.
So
I'm not a mechanic, by the way. That's just I messed with a carburetor once. I stayed
a Holiday Inn last night.
That's the one thing I hate about myself. I just can't. I'm not any good at mechanics, bro.
Oh, I'm great at mechanics.
Unless the parts are manufactured right and I have directions how to assemble them, forget about it. I'm not going to make parts.
And here he's showing that water is part of what's coming out of your exhaust now once you have that HHO going in the carburetor with the gas.
Right. When you get that hydrogen out of the water and you kind of extract more hydrogen out of the water that way, turn it into the mist state or whatever, the gas state, and you funnel that into your carburetor, into the intake manifold. That's air. It's sucking in air already at that point. It's going to suck it in for you, that mist,
Okay, so is it, just real quick, is it more fuel efficient that way, or what's the...
Yeah,
I think so, because you're gonna add hydrogen to the air from outside, and that hydrogen is what is being mixed with the liquid gasoline anyways. It's hydrogen. You want more hydrogen in your
30 to 50% more efficient by mixing in the hydrogen water with it.
Yeah, the more hydrogen you can add to your fuel that you get at the gas station, the more better your combustion will be.
Okay.
All right, guys. I'm gonna head out. My stream crashed twice already.
See you, Ben.
All right, Ben. Have a good night.
All right, my son, Ben.
Everybody.
Yeah,
guys.
See you, Ben.
Good night.
So I've run on a lawnmower, right? And you take the fumes from the lawnmower inside the tank, and you can run them directly to the carburetor, and the thing will run. You don't even need the gasoline. You just need the fumes.
You don't. If your fuel cell is making a good enough saturation of hydrogen, it will ignite in the chamber with the spark. It just needs enough saturation of the hydrogen from the water, from the fuel cell breaking up the water into hydrogen and oxygen. The oxygen gets left in liquid form. The hydrogen is broken off in gas form. Some of the oxygen goes in gas form too, but less. So it's
There's
the majority
something going
of
on in the background.
It really depends on your fuel cell plate, what material it's made out of. Like I said, I mean, if it's platinum, it's way less oxygen. It's taking a lot more hydrogen and filtering the oxygen away. That's what platinum was it? Yeah, platinum. That's what they use in fuel cells. They call them PEMs, proton exchange membranes. That's what your typical fuel cell is made out of. So you can give this thing water and give it a little power, and it'll turn it into hydrogen gas.
All right, Mike, we're going to move on to
so
this next one.
Burn.
Right. So this, I guess, was from the Walter Russell museum or group or institute. And this guy's working it now. And he's built, I guess, the first replication of Walter Russell's 0-point energy machine design.
All right, this is going to be unintelligible. Hold on.
So Walter Russell, he's mainly focused on vortex stuff.
So stay tuned for that. And I do invite you, Neil. In fact, I challenge you and your colleagues to reproduce this experiment on your own. And if you'd like, I can provide the measurements and all the equipment that we used for this demonstration experiment. And I look forward to hearing your results, sir.
Oh.
Stupid music getting us copyright strikes.
Yep.
Be misunderstood. But to be misunderstood is not to be a genius. The work of Russell, Walter Russell, has eluded any experimental support. Science is about reproducibility. That's how science works.
Yeah, I'm going to stop it right
such
there.
a shill.
I don't like that guy.
No,
he's
such a shill. So this video...
Well, you know, William deGrasse Tyson has never done any, replications and shown them.
Right, he's trying to claim about
dude, you got all the credentials. Do a
yourself.
replication and let's see you in the lab. Let's see you perform, man.
Yeah, I don't like listening to that guy. not in any way, shape, or form.
Oh, it's proprietary. You can't see me perform. I get paid too much.
I agree with you, Nathan. I don't like that guy, the Tyson deGrasse, I think, and the other one. His name is Michio Kaku, like that Oriental dude. Yeah, I don't like to listen to neither of these two people because I feel like all they do is misinform people about true things. Like they push away people from new ideas. Yeah, I agree.
Absolutely, Lulu.
Yeah, I agree.
So this video was
done in review of
Neil deGrasse and Tyson. They're like, F you, Neil deGrasse, and Walter Russell's stuff is real. So then they made at the Walter Russell Institute, and they made, if you fast forward a bit, like halfway through, I think they'll start showing the actual dual vortex machine thing. There we go, that thing right there. So here they've replicated a part of Walter
So when I turn
Russell's...
the power on, you see immediately. So we're only putting a half volt through it, but we got 2 amps, 2.5. And that means that amperes are flowing if they flow. I'm not saying they do, but if they flow, they're flowing through that coil now. And you can see.
Oh, that's cool.
Do you see how it's making a ball?
Mm-hmm. No,
it's making a sphere. And actually, even if I touch it, right, it still wants to form that spherical pressure gradient, as Russell called it.
Can you add a little more just to show how it will go to the spherical?
Yeah, it always wants to go, not toward the top of the thing. Right. It's bulging in the middle, which is Walter called oblation.
Because I'm going to show this to some flat earthers, and I don't want them to think that when you touched it with your hand, that's actually proves that the earth is flat.
Yeah, and the other thing is I can run this experiment vertically, and it still makes a sphere. So no matter your axis, if the axis goes in that direction or if the axis goes in that direction, it still makes a sphere because the equator of a conical magnet is not a straight line. It's a curved equipotential gradient, and we're creating it on both sides. So it's like focusing 2 convex lenses at each other. You create a spherical gradient.
If they're a flat bar, you have this kind of rounded, and as you shape it, it comes together as a sphere between them.
Yep. So just to prove the point that it's the electricity creating the field, if I turn the power off in 3, 2, 1, you can see that the filings are no longer suspended, and we're back to 16 volts.
Yep.
So there's no current flow now.
Nathan, didn't I
and
show
you can
that
see
video?
how If you zoom in, do you see how there's some residual
This is very
magnetism?
interesting. I forgot where I found it.
That's because of the compression. If I were to magnetize this end, there's absolutely no residual.
Right.
So there's even now flux residual magnetism in the core, but only at one end of the magnet, not at the other.
That's what concentration is.
Because of this
That's
compression
conical.
effect. And Walter said we only ever create energy by compressing from the outside in, like you pump air into your tire. You can't actually have in this universe a force of attraction that pulls from within the center, as Newton described in his concept of gravity. There is no inward pull. It's everything's being electrically compressed
from the outside
in.
Okay. So matter's
That's
frozen
so hard to
into place
Yeah.
versus pulled into place.
Now, what does that mean for physics? Well, basically, you can take the strong nuclear force and the weak nuclear forces and throw them in the trash can.
Yeah.
Because there's nothing forcing or overcoming the protons to slam them together with neutrons, which are nonsense because you can't have neutron charged matter. It makes no sense to have neutral charge. All matter is positively charged relative to space. And then it negatively discharges back into space, but it's never negatively charged and it's never neutrally charged either. So
up to some.
Yeah, there's just two
basis
potentials.
of a round
Always
point
another
zero.
potential.
Yeah, sure.
So this whole concept of charged particles and fields and everything, we can basically, Russell said we have to start over, just scrap the whole thing, because it's not a field of charged particles. We actually have light at rest, which we call still magnetic light. And then there's light in motion, which we call the electromagnetic spectrum or colors.
Sure.
So essentially hot light is what we call matter. And when matter's frozen in that hot condition of concentration, it becomes the elements of matter that we have in our periodic table. But as soon as we set something on fire, as soon as we melt anything, it becomes invisible. We call it gas, and then we can't see it anymore.
Right.
We send it back to the zero.
It becomes tenuous. It's
That's the easiest way to
expanded
put it,
beyond
right?
our sensory range.
Right. So now I'll show you, I'll disconnect the solenoids in the pair way. And I'll just pull one of them out, just a single one.
So this is done too with toroidal magnets. They do this, and trying to do fusion.
Yeah, pinch effect that they create in a tokamak or a fusion reactor or anything like that. They're trying to create compression, magnetic confinement.
Right.
They're really, Russell said they were actually pretty close with that one because he says the whole universe is a pinch effect.
Yeah.
Even though that they're considering it to be this exotic form of, creating matter, but essentially all matter is created that way. But they're doing it in a tube,
right,
to try to get it in a cyclotron, right? Why don't you just create compression from two ends and hit each other from both sides?
Yeah.
Instead of trying to accelerate towards speed of light.
Yeah. So, a disc rolled into 3D as a cone, and that's really.
So I just have some iron filings here. Yeah, now this guy, Erwin Mueller, photographed atoms.
Okay.
And what he found, and it's quite clear in the photos, is the center of the atom is vacuum.
This is tungsten.
Yeah.
Where's the nuclei?
So they don't have protons and they don't have neutrons.
What?
And
What
that's why I say you can
photographs
throw
are
out
these?
strong nuclear force.
What technology?
Nuclear force, there's nothing there to hold together.
So it's a lattice of atomic structure of tungsten, but you see at the center.
Yeah, that's amazing.
Yeah.
Okay.
So it's not like we're just pulling stuff out, but this doesn't equate to a black hole either. There's no force of attraction inside of that.
Yeah.
And the reason tungsten has a hole, Darren, is
because it's after carbon.
Right. So
carbon's the only one that we would look and that it would seem to have a nucleus.
It'd be fused.
Yeah. That's the only one though. Walter said all the elements are metals, even chlorine, which is a gas. as a metal, and he said there's only one non-metal, which is carbon.
Okay.
Check that out.
Yeah, that's Erwin Mueller's work.
That's a great book to have too.
And that was published in the 60s. So why do they still teach you about putting the balls on the sticks as the atom and then putting them together into molecules? Because that's not nothing like what it really is.
No.
So now I'll turn that on, right? And I can touch this. So do you see how that end of it can pick up a lot? A big mass of filings, right? See that?
Mm-hmm.
And I'll turn it off to show you that it's the electricity, right? It's the electricity around the cone in a vortex that creates that compression. Now I'm going to flip the magnet over and turn it on. So you see how it does not pick up as much. And what we do pick up is only around the outer ring edge periphery of that base of the cone. And this is also exactly what Walter Russell said would happen, because the magnetism isn't at the center. It only appears to be at the center when it's compressed at the other end. And then you can pick up a lot more. And then I'll turn it off, and now it drops it up at either end. So there's nothing there now.
Yeah, very cool.
Oh, it's just a proof of concept.
That was
pretty
cool.
Decent, eh? Pretty cool.
I like that.
As do I. Well, I guess you've been going almost 6 hours here, so should probably let you get back to your regular life and regular experiments. Or anything else you wanted to cover here?
No, man, we're pretty much done, man. I'm just mapping out my gravity flyer. That's the last thing I'm doing, man. It's
nice.
We're working with the two different waves, the transversal and the longitudinal waves, and we're getting a Mercedes out of it, a sign.
Yeah, I watched your update video yesterday on that. So it's like you're at the point where you're no longer feeling comfortable of running the experiments in your garage. You got to get out to the field now for that pop-up, right?
Yeah, it's dude, it's loading the field. The field bubbles on this, man, are just crazy. They're just everywhere, like way out there. And if you ran in your garage, you just blow your computer immediately as soon as you hit the button. And thankfully, my ZVS circuit works beautifully. This thing, man, you hit the button, it amplifies perfectly every time. It's just hard to hit that point. But when you do, man, it starts to do it. So the only thing I didn't have on was my high voltage when I'm testing right now, because I'm just mapping out the button. So I just want to see the other interaction. As soon as I put that in, man, I have a feeling we're just going to be, you know what I mean, hitting another level. So that's all I got.
I look forward to seeing it when you're ready to release it and get it.
That's going to be cool.
Right? People will be reading about it for generations to come, I think.
Yeah, well, we got to give a credit to Alexi as soon as we're done, man. And, it's not my device, it's his. I tried to keep it as much as original as I could.
For sure.
So.
Right, it's international working together on the fringe, because fuck the governments that want to start us fighting and killing each other.
Yeah, no
Instead,
kidding.
let's just work on anti-gravity and get off this planet and not have to shoot each other. Right?
Yeah, no kidding. Yeah, forget all that stuff. They're just starting wars everywhere now.
They really are. It's kind of scary.
Yeah. So. All right, guys. It's what?
All right. Much
5
love.
minutes, 6 minutes.
Thank you, gentlemen. Great podcast.
Thanks, guys. Thanks, everybody, for showing up, man. I really do appreciate it. Thank you.
Thank you,
thanks
Mike,
for having me.
Nathan, Bernie, and Ben.
Much love, Lulu, Mike,
Hope you guys
Ben,
have a great night.
Sarah, and Gerald earlier. And much love, guys.
Bye-bye.
Talk soon.
All right, guys.
Experimentations.
Have a good night.
Later, guys.